Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about software Schematic Manager and WinCC Flexible to create the example auto control, the VFD, on-off control for control the level bin of material. Okay. So in the previous video, we already learned about how to create the FC, it means that function, and we already simulation for this objective. And in this video, I will connect it to the real PLC. It means that use the standard software for connect to the analog input card, and I will use the digital output for control the VFD. Okay, and the concept is when level greater than or equal 10 tons, it means that nearly full, it will start the VSD, and then motor will run for discharge the material. Okay, and if the level is decreased to less than or equal 25 tons, the VSD will stop and the material will stop to discharge out. Okay, so this is the concept. And before go to create the program for auto control, I would like to explain a little bit about the drawing of analog input. Yes. So here is the drawing of analog input that we already learned in the previous video. So I will use channel 1 for terminal number 2 and terminal number 3 for this level. Okay. And one more for standard signal. Here is the standard signal. Right now I will use 4 to 20 milliamp. It means that 0 to 27,649. Sorry, 48. Okay. 0 to 20 milliamp or 4 to 20 milliamp. Okay. So let's go to our software to create the program for auto control. Okay. So the first, let's open SIMATIC Manager software. And I will use the existing project that we already learned in the previous video. So this project. Yes. In the previous video, we already learned about how to create the FC2 for analog input. Yes. And I would like to inform that I just change a little bit from 32,000, yes, just example in the previous video, to the standard signal, yes, to here. Yeah, 27,648. It is the standard signal of PLC S7-300 from 4 to 20 milliamp. Okay, so let's change a little bit for our formula. Okay, so let's change to the maximum. Yes, 27,648.0. Okay, let's save. And I will use the FC2 to generate or convert from level, from raw data from analog to level. Okay, so first we can drag and drop the FC2 to our network. Yes, so I would like to insert one more network. Example, level Hopper. Yes, and then I will drag and drop the EP2 to our network. Yes, and for this one we need analog input signal, right, from okay, from standard source or from the analog of level. Yes, so let's check hardware configuration, which address that we will use. Yes, so right now I already connected the cable to channel number 1 of this one. So it will start from PIW 256. Yeah, so we can write PIW 256. Yes, and this is a high scale. Yes, example 0 to 150 tons. So 0 to 150.0, and this one 0.0. And here is the output that we will take it to show on HMI. Yes, example MD 20. Yes, okay, so we can save and then download to the PLC and then can online to check. Okay, so right now it's so 150 ton because I already put the 20 milliamp. So let me adjust. Okay, let me adjust the milliamp to 16. Yes, 16 it's so around 2 tons. Yes, 12 milliamp. 12 milliamp. 8 milliamp. Yes, and 4 milliamp. It show 0. Yes. Okay. Adjust to 12 milliamp. So right now the level is already shown. Yes, the same the rank, follow the rank that we already setting. Okay, so right now 12 milliamp around 75 tons. Yes, so please back to our slide. So I will set greater than 10 ton. It will start the VFD, right? Okay, so we can go to create the interlock. So I will create one more network. Yes, and this one if MD 20 greater than 100 ton, then VFD will start. Okay, so I will use comparator. Yes, for real. Yeah, greater than equal real. So if MD20 greater than 100.0, right? Then I will set the one output to start VFD, right? To control the relay. So let's go to bit logic and then I will use set coin. Yes. I will use set coin. And let's check the address. Go to hardware configuration and I will use person Q or Q 12.0. Yes, that I already wiring the cable to relay control. So Q 12.0. Yes, already tested, right? 12.0 here. So maybe I will delete all the network first. Yeah, keep only this, and I will rename this one to be command start VFD. Yes. So greater than 100 tons, it will start the VFD, right? Okay. And if lower than equal, okay, so I will use lower than, less than real, yes. And this one less than 25 ton, right? Then I will reset this one, yes. Reset this one, it means that reset the VFD, yes. Stop the VFD, okay. So this one, if less than, right? So less than or equal, greater than or equal, greater than or equal, yes. Less than or equal, it will stop VFD, right? Okay. Then we can save the program and then let me download and then online for monitor, yes. Okay, right now the MD20, right, is 75 tons. So the VFD is stopped, right now. So if I increase to greater than or equal 100 ton, the output is turned on, yes. Let me show. Okay, can see here is turn on output, yeah, from here. So if I adjust to be less than 100, the VFD not yet stopped because it's not yet less than 25. Yeah. So if less than 25, it will stop the VFD. Okay, it's still stop. So 100 something, it will start again. Okay. So we can create the HMI for test. Okay. So let's go to WinCC Flexible. And then create the empty project. And let's go to the panel. Yes, I will use TP177B 6 in color. Yes. Okay, and the first step, we need to create the connection, right? So double click on connection. Example HMI1. Okay, connect to S7-300, and I will use Ethernet, and here is the IP address of computer. So 192.168.0.253, and this is the IP address of PLC. Yes, so 192.168.0.1. Okay, and we will create the text, right? So double click on text, and the first one we need to create the level, right? So I will create insert one more hopper. Let's go to graphic and then go to the WinCC Flexible image folder and go to the symbol and go to the 4256 color, okay, and go to the tank. Okay, thanks, and insert some tank that we like. Okay, right now I will use this one hopper. Yes, okay, and let resize a little bit. Yes, and then we have the motor, right? Design the same as my picture here. So let's go to motors. Okay, motors, and go to motor. Yes, I will do this one. Okay, just example, so no problem. Okay, so I will draw the screw. Yeah, to draw the screw conveyor, we can go to the sample object and go to rectangle. Yes, example like this. Okay, and then I will use line for screw. Yes, just like this, and then copy one more. I will copy this line, Ctrl C, Ctrl V, and rotate this line. Yes, okay, this is just example, so everyone can draw the line that we like. Okay, this is just example for easy to understand, so I will copy and then paste. And one more. Yes, like this. And then I will draw the discharge by use the polygon. Example discharge like this. Yes. So when motor is turned on, it will run the screw and then it will discharge the material. Okay. So I will adjust this one a little bit. Yes. And we will have the VFD, right? So let's go to library. Yes. Go here. And then go to the my picture image. Yes. In the folder, right? This one. Okay, it will come like this, so I will resize a little bit. Okay, so we need to design the VFD, yes, that I already copy from my picture, yes. It is just example. Here is the VFD, yes. So we can draw, yes. For VFD, we have input power for supply, right? Yes. I will use a polyline, easy to draw, yes. So example, this is a line input for supply. Yeah, for supply the VFD. Then the output of VFD will connect to the motor, right? It is the, I just draw the single line, yes. Yes. Example, connect to the motor. Okay. Like this. I will resize to be bigger than this one. Yes. So we have input, right? For example, 380 volt AC, yes, connected to the input of the VFD, and the output will connected to the motor, right? I will adjust a little bit, yes, to be like this. We can design, yes, actually we can design the style that we want, and this is just example, yes. So I just put like this for screw conveyor. Okay. So for input, I will put the color green, yes, and this one I will put color red first. So if the output is turned on, then I will it will show the green color also, yes. So the next step, we will use the level, right? So 0 to 150 ton, yes, for this level, yes, like this. And we will create the text, right? So I will save the project first, and we need to create the text follow this one, right? So the first one is level, yes, and the second one is the output, right, for control the VFD. So let's create the level, take of level, yes. So example level hopper, yes, it is the real, yes. So real, and start from the MD20, yes. So MD20, yes, MD20, yes. And the second one is the output, right, for start the VFD. So Q12.0, yeah, start VFD. It is the boolean, right? So M12.0, yes, and we can comment a little bit. This one level hopper, level of hopper, and this one for command start VFD. Okay. So for level, I will put the text, yes. So we can choose the text level hopper, yes. Sorry, we put like this. It is the process, yeah. So we put on the process. Okay. And the second one, we can use the rectangle, yes, like this. Example, this is the signal start the VFD, yes. And I use red color. And this one is the change color when the VFD is run. Okay, so VFD. Okay, start VFD bit, and it will green, yes. Okay, it is one, it will green color, and this one also go to animation and then choose the start VFD and change to green also. When it become one, it means that it turn on. Okay, so we can save the project, and then we can simulation, yes. So let's simulation. Okay, right now the level, I will choose one more for show the level, yes. So I will use the IO file, yes, here. It is the output only, right? Level hopper, right? .99. And I will zoom a little bit, yes. Okay, let's go to property and then go to the text. And then I will change to the center and middle, yes. And I will change the color a little bit for easy to see, yes. Color text, it means that green, and the background should be black, yes. And then the unit should be done. Yes. And then we can change the color to be yellow, yes, example. So we can save. Okay, good. And then we can simulation, yes. So right now we can see the level hopper around 74 tons, yeah. And the scale is here. So the VFD is stopped, okay, right now. So if I adjust the level, okay, I will adjust the level, and let's see the status together, yes. So if I adjust level to be like this, decrease, yeah. Okay, the relay will off, yes. But this one should be change the color, right? Because 12.0, right? Let me change a little bit, yeah. For animation, let's go to text and then go to this one should be Q, right? No M, because we take the Q 12.0 to control the VFD, right? Okay, let simulation again. Okay, so right now the VFD is stopped, yes. So let me, because the hopper is lower than 25 tons, so let me adjust to be greater than 100. So I adjust the milliamp. Yes. Okay. The output is turned on. Because level is over than 100 tons, right? Okay, and the VFD is run also. So when the VFD run, the motor is run. So I will change the color of motor a little bit. Yes. Okay, let's use the. Actually, we can copy from this one to this. Yeah. Because when VFD turn on, the motor will turn on also. Yes. So motor will run if VSD run. Okay, right now the motor is running. Yes. So let me adjust the milliamp to decrease. Let's see the result. Motor is stopped or not. Yes. Okay, so let me adjust the milliamp. Yes, little bit to see the condition of the VFD. Okay, so right now the VFD is stopped. Yeah, because relay control is not on. Yes, and the condition of VFD here is turned off also. Yes. So this is the instruction how to create the on-off control for VFD controlled by level hopper. Yes, it's very easy that we can do like this. It is very simple because we just take the level signal of level to turn on and off the output, and we can connect the cable from the relay to control the VFD. But the VFD is still control the speed of motor by fixed speed. And in the next video, I will show and share about one more mode control that we can do also. Okay, we can set point for fix the speed. Example, when the level hopper is 100 tons, we can adjust the frequency to be example 30 Hertz or something. So thank you very much for watching my video. So if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone. Welcome back to my channel again. General Technology Knowledge. Today we will continue our program that related to Schematic Manager and WinCC Flexible to start-stop the VSD and control or fix the frequency of VSD by using the level hopper to control. Okay. In the previous video, we already learned about how to start and stop automatically to the VSD by using the level hopper to control also, and it just on off control. But in this video, we can call on off control also, but we have the fixed speed. It means that fix the frequency of the VFD. Example for level low, the motor will run 25 Hz, and for level high, the motor will run 45.5 Hz. So we can do like this. Yes, and I will using the software SIMATIC Manager version 5.6 and WinCC Flexible to design the screen for start and stop the process and fix set point the frequency of VFD. Okay, so let's go to our software to create the program. Yes, so first open SIMATIC Manager, because we will use the existing project to modify some program. Yes, so let's go to block. Yes, and then open the OB1, and we need to create the start and stop the motor, right? So I will use this one for start and stop the motor. So I will create one more network. Yes. Okay, I will cut this one to here, and then I will start and stop the motor here. Okay, so I will copy. Yeah, I will cut this one to here, and I will insert a command start stop the VFD. Yes, and then we can use the button stop, button start, and for hold the signal. Sorry, we can use this one and cut this one to here, and I will use the coil. Yes. Okay, so for this one I can use M 0. Example M 100.0. Yes, this is for start the VFD. Sorry, stop VFD. Command stop VFD. Yes, and this one for command start I will use M 100.1 and edit symbol, and this is a command start VFD. Yes, and this is a VFD. Yeah, dry start. Yes, or VFD start. So I can use M 100.2 for VFD start. Okay, VFD start. So if we start the VFD, so we can fix the speed followed by set point, this one. Yeah, so this one I can review the command. Yeah, revise the command. This is a command move to analog output. Okay, so if this one on, it will move the value 45.5 Hertz to the VFD, right? Okay. So if level increase to 100 tons, it will allow this one on, and this one will move. Yes. So I will move the network. So this one should be revised also. Yeah. So if MD20 greater than or equal 100 tons, then move value 45.5 Hertz to the VFD, right? To VFD. Okay. So I will insert one more network. So we can move the value. Yes. Okay, so I will use move. Yes. For 45.5 Hertz. So 45 move 45.5 Hertz equal if we think about the raw value equal 159 around 18.57 milliamp. Yes, to the analog output. Okay. So if we would like to run the VFD around 45.5 Hertz, so we must move this raw data to the analog output. Okay. So I will move 25159. Yes, to analog output. For analog output, we can check on the hardware configuration. So let's go to AO. Yes, and I will start from address 272. Yes, and it is for to 20 milliamp. Yes. Okay. So PQW 272. Yes. So if this one on, yes, so copy and paste. I will move 25159. It means that around 45.5 Hertz to the analog output, and then we can connect from analog output to VFD. Okay. And one more, if I would like to fetch speed also for this one, level low, I will let motor run only 25.0 Hertz. So I can move. Yes. So move 25.0 Hertz equal 13824 around 12 milliamp, right? To analog output. Okay. So if this one not run, okay, this one not run, right? This one not high, it means that it's low. So I will move, yes, 13824 to this unlock output, right? So this one we can command unlock output. Okay. So the first one we should start, right? So I will let this one start first. Otherwise it not work, right? So I will end with the start. VFD start. Yes. This one. This one also. Okay. And then we can save the project and then download to the PLC and we can online. Yes. So the first step we must start the VFD, and second we can move the value. Yes. Okay, so let's go to our WinCC Flexible software to create the screen. Yes. For control the motor. So open WinCC Flexible and then go to the existing project, yeah, Hopper, that we already learned in the previous video. Okay, and then let start create. Yes. So I will change this tag for VFD start. Yes. This one should be M 200.2. Yes. So M 200.2 bit 2, right? VFD start. Okay. And then command start VFD, right? So command start cmd start VFD 200.1, right? So command start VFD and one more command stop, right? cmd stop, sorry, stop VFD. It will start from 200.0. Yeah, here stop. Sorry, 100. Sorry, 100.0. Yes. Okay, I will change this one to 100. Okay, 100. 100. Stop. Command stop VFD. Okay. And then we need to view the frequency, right? This one. 45 Hertz, 45.5 Hertz, and 25 Hertz. Okay. So I will adjust this one little bit. Yes. Okay. Adjust this one a little bit. And I will put the stop and start button. So this one stop. and then I will copy this one for start button, right? Start VSD. Yes. Okay, stop and start VFD. And then we will change the color of animation of the motor, right? So this one we can use the IO file, yes, or I can copy from here. Yes, for a frequency, right? So this one we can fix speed, right? Frequency, and this one also frequency. I will adjust a little bit because we have only this one, yes. Okay. This one we can remap for frequency. Yes. Okay. Yes. And I will use the unit hertz. Okay. I will change color to be yellow. Yes. Actually, we can use the property for change this color also. Example, I will use this color. Yes. And I will change this one to be white color. This one also white color. Yes. Easy to see. Yes. This one white color also. Okay. And this one stop I will change to red color. Okay, and this one should be green. Okay. And then we can configure the button start and stop, right? So let's go to the property, go to event, and for the start and stop we can use this one momentary button, right? So we need go to press and then set bit start VFD, sorry, CMD start VFD, right? This one stop, so I use stop. For release, so reset bit, sorry, CMD stop also. And this one for start, I go to press and then set bit CMD with start, right? And one more for release, reset bit CMD start. Okay. And then we can monitor the frequency, right? This one for frequency set point, and one more we can monitor the frequency output to VFD, right? So I can drag and drop this one to put here, and this one for actual frequency, right? This one I can delete because we used to start here. start frequency, start VFD and start the motor. It is the same command. Okay. So I will change this one a little bit, yeah, for unit. Okay. Okay. This is the actual frequency of the VFD, and this is a set point for low and high level. Yes. This one for high, so I can write H. It means that level high, or I can write LH. Okay. And this one for LL, it means that level low. Okay. So level low, we can use the other frequency, and for level high, we can use other frequency. Okay. So this one I will change the color to be go to color animation and then change the text. This one for VFD start, right? So VFD. Okay. And this one also, yes. Start VFD, yes. Okay, so that's all. So in this set point, I keep first because we not yet to implement. I will implement after I simulate this one. Yes. So this one no need to put the address. No need to put the text. Yeah. Let me compile. It have error or not? Yes. Okay, no error occurs, so we can simulation. Yes. But this one is the actual of the VFD, right? So I need to get this point. Yes. So PQW, it is the word memory. Yes. So let's go to add the text for word memories. So let me test. Actual frequency. It is the word, right? So we can use word and PQW 272. It is the actual VFD frequency. Yes. So here I can convert, yeah, use the actual frequency, yeah, but we can convert the range. So go to the linear scaling and then go to enable. So this is a PLC raw data. So it will start from 0 to 27,648, and this is the show the HMI for hertz, right? So 0 to 50 hertz. Yeah. So let's test. Okay. Let's test again. Okay, we can not convert, right? So we cannot see the frequency, right? So let me change the program a little bit. Yes. So the first I would like to change this one to be like this. I will move to MW 0 first, yes, and this one should be MW 0, yes, and then I will move, yes, I will use function move. So move MW 0 to PQW 272, yes, sorry, PQW, okay, and then I cancel and then download to the PLC. But before move, the VFD or motor will be run first, and then if the motor not run, yes, I will move 0 to PQW 272, okay. So let's save and then download and then downline, yes. We will choose the NC because when motor not run, then the move 0 to analog output, okay. So let's revise the text of the WinCC, yes. I will use this one word and then use this one for MW0, right? Okay. And then let's go to text, and then this text we will use the linear, yes. Okay, use this linear. So 0 to 27,000 and 0 to 50 hertz, okay. And then let's test again. So simulation again, okay. So right now motor is running and it shows 45 hertz, yeah. If I stop the motor, it will move 0 to the VFD, right? Okay, so I will start again. So let's check from the top. So right now the motor is running, right? And level around 81 tons, yes. So I will adjust the level. So let me show the actual PLC and multimeter. Okay, right now the milliamp around 18.58 milliamp and motor is running. So if I adjust the milliamp of input to less than, yes, so it will run the 25 hertz, yeah, around 12, yeah, around 12 milliamp, sorry, yes. So on the touch screen also 25 hertz, yeah, around 12 milliamp. So if I adjust again to be it means that I will increase the level of hopper. The motor will increase the speed also, right? Okay, let's see here. The motor will increase the speed because milliamp around 18.58 58, yes. So motor will run around 45 Hertz. Okay. And one more, we can setting the frequency to the PLC also from HMI by set here. Okay, so let me show. So here we not fix the speed, right? Here. So if we would like to increase the speed by following the HMI, we can do here. So example MD, or we can use MW, example 4. And this one, I will use this one for 4 for increase, and this one for 8 for decrease. Yes. Okay, so let's download and then online. And then I will use the WinCC for adjust the speed, right? So I need to create 2 text more. Okay, the first one is LH frequency. Yeah. So we can use word and we can use MW2. Yes, I will change. So frequency for level high. So MW2 LL frequency. It means that frequency for level low. Yes. So I will change the program a little bit. So this one should be MW2. This one MW4. Yes. And then we can save and then download and then online again. And we need to create the screen, right? So go to WinCC and then go screen. Yes. Because we need to add the text that we just insert for set point, right? So example this one, we can choose input and let start to this one. Okay, level high, and then let's go to the linear. Yes, linear scaling, and this is a PLC. So if we would like to use the 50 Hertz, we can use 27,648. Yes. Okay. And this one also, yeah, this one should be only 2 because we have only 50 Hertz, right? This one also, go to the level low frequency, yes, and go to the property, linear scaling, and change this one to 50 for HMI, and this one for raw data, right? So 27,648. It is the standard signal of analog, right? Okay. Yes. Okay, so let me zoom a little bit. Yes. So in this case, we can set point. Yes. Let me test. Okay, first make sure the motor, our motor is running. Yes. Okay. So let me set point. Example, I would like to set for level high around 30 Hertz. Yes. Let's see, here is 30 Hertz. And for level low, I will set point. Oh, this one cannot set, right? So I will change to input also. Yeah, this one output, so we cannot set. So we will change to input. Save again, and then simulation. Okay. And I will set this one to 30 Hertz for level high. It means that when level high, it will run 30 Hertz, and for level low, it will run 10 Hertz. Example, yes. Okay. So right now the level is high, and then it will run 30 Hertz, right? So let me adjust the level. Yes. Okay, right now I will adjust the milliamp for level. Okay. 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 So right now it run around 10 Hertz and milliamp through the VSD around 7.2 milliamp. Yes, it is correct. The same as we fetch speed from the HMI. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I'm also sorry if I have mistake in this video also. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to use Schematic Manager version 5.6 and how to use the function, it means that FC, to control the frequency of the VFD by using PID control. Okay. In the previous video, we already learned about how to increase or decrease the speed of VFD by using the on-off control to control the speed of the motor screw conveyor. Okay. So today we will continue to create the PID control. Yes. And the concept is, if I would like to set point the weight of the hopper, example 80.5 ton. So if the hopper is less than or greater than 80 tons, it will adjust the speed of the motor by using the analog output that control from the PID to adjust the frequency of the VFD. Okay. So let's go to our software to create the PID control. Yes, let's go. So first open Schematic Manager. Yes. Now we use version 5.6. Okay. And this is the existing project that we already learned in the previous video. Yes. So in the previous video, we already on-off control the VFD, yes, by adjust speed by manual mode. Okay. So today we will create the PID control. So to create the PID control, we can use the same as the previous video that I already showed. So let's go to create the organization block. Yes. Example OB certified. Yes. And I will use ladder for language. And then go to the open. Yes. And then we can comment for this network. Example create PID control for level hopper. Okay. And then go to library, and then go to standard library. Yes. And then go to the PID control block here. And right now I will use PID control for FB40 first. It means that continue control. Yes. So drag and drop the FC48, sorry, 41. Yes. And this one I need to put the DB, right? So example DB 41st. Yes. And then we will create the DB 41st automatically. Yes, here. So here we need to put some parameter, yes, to control. Example, the output, the set point, yes, it means that SP, yes, set point value. So here we need to control, yes. Example, we need to manual mode, so we need to put the some boolean, yes. I will put M, example 20.0, yes. And deselect we can put also, but negative. Example M 20.1, yes. And we need to put the cycle, right? So example T, yes. $100 millisec, yes, or 1000 millisec. And the SP we need to put the some address, right, to set point from the HMI. Example MD 30, yes. And for the output we can put another memory, yes, that we want. and we need to put the memory, yes, for output, example MD40, yes. Okay, so that's all for parameter for PID, yes. So let's save the project, and then let's go to OB1. Okay, the first I need to delete some existing program that we already learned in the previous video, because it's not related to this section. Yeah, so let me delete. Okay, that's all. I just put only this one because we need to use for scaling. So this is a level of the hopper, right? Okay, level of the hopper. So here is the PV, so I can put the data that link from the DB, right? Link from here. Let me show. Because if we created the PID block and use the DB, we already automatically create this. Okay. So here is the PB, right? So db41.dbd10, right? It is the PV in. Yes. So here I can put db40 first dot dbd10. Okay. Because we need to transfer this PV to control the PID block, right? It means that process variable feedback. Yes. Okay. So that's all. So we can save the project. And then we can download to the PLC. Yes. And one more thing, we can use the feedback from, it means that the output from the PID, right, to control the analog output. And then we can connect the analog output to the VFD, right? So basically I can use MD40, yes. It means that output from the PID. So let me online this one first for easy to understand. Yes. Okay, so we can online. So right now the hopper around 54.6 tons. Yeah. So let's go to WinCC Flexible to create the screen for PID, right? Okay, go to the existing project and then go to the hopper. Yes, this is a existing screen that we already learned in the previous video, right? So for start stop the button we still use, right? And the signal of VFD run we also still use. So let's check the text again. So command start, command stop, and VFD run we still use, right? Okay. And for the actual frequency, it should be shown on the HMI, right? So we need to create more screen for control. Yes, it means that we can set point or we can monitor the frequency of VFD, right? Okay. So to create the new screen, we need to create the text first, right? So in this case, we need to create some block that related from the PID block, right? So basically, we can add some parameter, yes, or some text that we can link from the PID block. So I will use add one more screen, yes, or here we can add all parameter for control also. I will adjust this one, yes, no need to create the new screen. So I will adjust this one for example set point SV. It is the sun, right? It means that set point, and this process variable PV. It is done also, yes. And this is a parameter. Yes. So we have a set point and feedback, right? And then we have a gain for adjust for tune the PID, right? So we have gain. Maybe I will adjust this one to be smaller than here. Okay. Okay, like this. And this is a gain, right? I will copy this one first. It is the gain, and then we have TI, TD, and TM leg. Okay, and then one more we have output. Show the output to the VFD also. It means that percentage that control to the VFD. Yes. So this is the output. Okay. I will copy TI, TD. Okay, I will adjust this one a little bit. Small a little bit, yes. Actually, we can do the same, yes. So we can align this one first. Yes, like this. Okay. and we can copy this text to use. Okay, example PB. Yes, we will put the text after we design this one finish. So gain is shorter than example 0.5 or something. So it is small. For TI, yes, T integrate, T derivative, this one show okay, like this. Actually, everyone can design the style that you want. Yes. Here I just example. Maybe I can adjust, align this one a little bit to here, and then move this one. Okay. Because we need to put the unit also for this parameter. Okay, so like this. So let me show the project first. So the first one, we need to create the set point value, right? Set point value, this one will be certified. Yeah, this one. MD 30, yes. So we need to create the new text. So PID SV, it is the real, yes. So MD 30, set point PID, right? So set point of PID, and then we need to have feedback, right? So for feedback here, it is the feedback. Sorry, this one is the feedback. Yes. So db 41st.dbd10, it is the feedback from the hopper. So feedback, or we can write PID PV process variable. Yes, it is the real also. So db1, sorry, db 41st.dbd10, db 41st.dbd10. Okay, it is the process variable. Okay, and the next for gain, right? So for gain, it will start from here. Yeah, for easy to understand, I will show this one. Sorry, db41, yes. Gain here. So db 41st dot dbd 20, right? It is the gain. So we can add gain. It is the real, right? So db 41st dot dbd 20, okay. PID gain, yes. And the next we need to create the TI, right? T integrate. So TI, it is the time, yes. And start from TI here. db 31st dot dbd 24, yes. Here PID TI, and the next step is the TD, right? So TD, it is the time also, and it will start from dbd 41st dot dbd 28, yes, 28. It is the PID TD, and one more for TM lag, right? Time lag of the deviation action, yes. So we can input TM lag time also, and it will start from dbd 41st dot dbd 32, okay. TM lag, okay. And one more for output, right? Output to frequency. So we not yet create the text for the PLC. So let's save the one first. And for SV, we can input, right? So SV, PID SV, yes. It is the tons. Example 9, it is a format 999.9, yes. Okay. And for PV, it is the output, right? So we take output PID PV, and it will show like the SV also .9. And for the gain, yes, PID gain, it is the input also here, and maybe we put like this .9, yes. Okay, I will adjust a little bit for gain. And then TD, right? So TD, it is the time. So PID TD, sorry, TI, it is the input also, and I will put yes, like this, because it is the millisecond, yeah. So I will put the format for 5 digit. The next for TD, right? So TD, it is the input also, and the format is the 5 digit also, millisecond. and this one also TM LAG, it is the input, 5 digit also. Okay, and for the output we not yet create the program, right? So not yet create. Okay, so let me save the project first, and then we can put this one, yes, for start and stop is the same, right? So let me simulation, yes. Okay, so let's open the OB1 and then online. So let me check the existing program can use or not. So start, okay, it work. Stop, it stop. Okay, so the next step we need to create the output, right? It means that create the analog output scaling for control from the output the PID to the VFD, right? Okay, so let's start to create. Before start the create the scaling, I would like to show a little bit for formula how to create the scaling of analog. Yes, so it is the output here. Output, it means that input minus input low scale multiplied by output high scale minus output low scale, and then divide by input high scale minus input low scale, and all this one plus by output low scale. Okay, so this is a general formula, and this is a simulation that I just do it because this formula I got from here. Yes, so example input is 0 to 100%. Yes, and for high input I will set 100, and low output I will set 0. Yes, and this is the maximum of analog output raw data, so I will set high output. So if I set 50% example, it will generate this raw data to control the VFD, right? Okay, so we need to create the scaling, this scaling on the formula for easy to convert. Okay, so let's go. Okay, I will save this one first, and then let's go to right click and then insert one more FC. Yes, and this one example scaling, convert scaling. Yes, and I will choose the ladder language. Okay, so first we need to input the parameter, the same Excel that I show right here. Input, yeah, the input is from the PID, right? Example, so we need to have input low scale, output high scale, output low scale, input high scale. Yes, so we need 4 parameter more, right? So the first one go to input, and then here we can type input, example input. Yes, I will use the integer, right? Yes. And we need to have the 4 parameter more, right? The first one is input high scale. It is the real. Input low scale. Low SC means that input low scale. It is the real also. And we have output out high scale, yeah, HSC. It is the real also. And one more for out low SC, it means that out low scale. Yes. And we have output, right? So out or Q, yes, we can write this one. So it is the real, right, for Q. Okay. So we put the same formula, yes, that we already created. Sorry, we must put this one to in. I will delete first. So we have click here, yes, then here input. So it is integer. So input high scale, input low scale, output high scale, output low scale, yes, and it is the real, it is the real, it is the real, it is the real also. Okay, so we need to create the block follow our formula. So the first I will minus between output high scale and output low scale. Okay, so we need to convert from integer to real first, right? So let's go to block. We can integer to double integer, right? Here, and then we can use the double integer to real, right? Yes. So this is the input, and this is we need to create the temp. Yes, temp. Example temp1, temp1. It is the double integer, right? Here is double integer. So dint, it is the temp1. And then we can copy from temp1 to the real, right? So we need to create one more for temporary, temp2, and this is a real, right? Real. So temp2, yes. So for convert, and then we need to create one more network for this. We can command convert from integer to double integer. Okay. And we need to create minus between output high scale and output low scale, right? So I will use sub real between input high scale, right? Output high scale. So out high scale and out low scale. Okay, and here I need to create a temp 3, and it is the real, right? So here I put temp 3. Okay, and then I will subtract also between input high scale and input low scale. Yes, so we can use sub real between input high scale and input low scale. Okay, and here I will create one more temp 4. Yes, and it is the real, so it is the temp 4. Yes. Okay, and then I will divide this one. Yes, so I need to create one more network. So I will use divide real between this one and this one, and I need to create one more temp, right? TEMP5, and it is the real. So this is a temp file. Okay, and then I need to multiply between this one and this one, right? So I can multiply real. Yes, between input. At input we can input input minus input low, right? So here I can use sub real. I can use input minus input low, right? Input low scale. So input low scale, and then I will create one more temp. So maybe temp 6. Yes, and it is the real also for data type. So temp 6. Yes. So I will minus between temp 6 and between this one, and then I will create one more for temp 7, and it is the real also. So temp 7. Yes, and the final we need to plus by output low scale, right? So I will create one more network. Yes, so add real. Yes, I will add this one with output low scale, right? So output low scale, and then I will put the output, right? This one. So Q. Okay, that's all for this one. So save the program and then go to the OB1. and then create the new network and use the FC1 that we already created. Yes, so FC1 convert scaling. Yes, drag and drop. Yes, we will got like this. So for the input, right? So input we will got from the PID, right? So I will put this one first, MD40, right? But we need to convert this one first before we can put this block, right? Because it is the integer and this is a real, so we cannot put. So I will add one more network for convert from real to integer. Okay, from real to integer. So I will use round. Yes, I will use round. From MD40, yes, here. And then I will generate for some memory, example MW 70, yes. And I will move, yes, this one to here. MW 70, yes. And for the rank, yes, for input it will reply from PID from 0 to 100%. So here I can put 100% for input, and for low scale 0.0%, and for the output high scale it is the standard of analog output, right? So 27,648.0, and this is 0.0. Okay, so if 100% from MD40, it will show 27,000 for the output, right? And then I will convert from here by using trunk. Yes, because we need convert to the analog output, right? So let me show the analog output hardware. Go to hardware configuration, and then it will start from analog output here, PQW272, right? So PQW272, okay. And this one we can put the MD45, yeah, example. Yes. So from output the PID, it will convert, and then it will generate the milliamp or volt to the analog output, right? So okay, save the project, and then we can download. Yes, all. Okay, I will close and then download the whole block to the PLC, right? By select here, and then we can download all. Okay, and we can start. Okay, and then we can online. Okay, okay, like this. So I can use like this, and then open one more block. For PID, right? Okay, like this, and then I can online. Yes, one more block, and then we will create the out, right? So let's go here, go to the text for output. Yes, and then go to this block. So here is the output, right? .36 here, it is the out. So this one is the out. Yes. So we can put db1, sorry, db41.dbd 72. Okay, it is the out. So this one output also, and this one the output. Yes. Save the project, and then we can simulation. Yes. Okay. So right now we can set point the level. Yes, this one should be like this. Level hopper, right? So PID PB. It will be like this. Yeah. Okay. So we can simulation again. So right now it show around 54.6 tons. Yeah. So if I set point to example 100 tons, so the output will working, right? So I will adjust this one a little bit. Example, we set point 100 tons. Yes. So the output is not yet so, right? So let me check the data type of the WinCC. Yes. Here is wrong. Yes. So we need to change this one to real. Yes. And then this one we need to change to percent for output here. and this is a percent. Yes. Okay, we can save the project again, and then I will adjust this one a little bit. And for unit, it is the millisecond for here. Yes. TD, TI, it is millisecond also. Okay. So let's simulation again. Yes. So if I set point 100 tons, yes. Let's see output right now show 100% because we not yet adjust the parameter of PID. Example, I set 80 tons. Yes. And for gain, I will set example 0.5 first. And then this one, not show, right? It is the millisecond. Okay, let's simulation again. Okay. For first, I need to start the motor. Okay, start. And then I will adjust the set point. Yeah, example 80 tons. Yes. And I will adjust again to 0.5. And this one example 2000, it means that 2 millisecond. 2000, it means that 2 sec. I just set first. Yes. So I will show the milliamp. Yes. So right now I set 80 tons, but the actual around 45.6. So if I set 40 tons, it will decrease the milliamp, right? By follow the time that we can set these parameters. Yes. So I will adjust this one to be bigger than this one. Example 3 millisecond. Yes. So I will show how it work. Yes. Okay. So right now I will adjust the uh, input. Yes. To less than the set point. Let's see the output is start increase, right? Follow the time that we set. Yes. Okay. So we can adjust the time. Yes. Example, if we would like to slower than this one, we can decrease the time. Example 9000. Yes. So it will work slowly. Example, this one I set 0.1 for gain. Yes, and I set this one to 100 tons. Let's see, the output is work, and I will show the milliamp output. Yes, so let's see, the output is working by follow the time that we set. So if I adjust the PV is greater than SP, yes, let's see, the milliamp is start decrease, follow the time that we set. Yes, so we can connect from analog output, yes, from here to the VFD to control, yes, the motor. Okay. So this is just example how to create the PID control for control the motor of the hopper by using the Schematic Manager and PLC S7-300. Okay. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you in the videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to add, configure and test the digital output module SM322-18801-0AA0. And I will use software Schematic Manager version 5.6 to make the configuration for add the module to the CPU. And here is the digital output module, and here is the serial number or module number. Yes, before go to make the configuration via software Schematic Manager, I would like to explain a little bit about how to wiring the drawing of this module. Okay, so let's go. So here is the digital output module that I already draft the drawing for easy to understand. Actually on the module, yes, go to the slide. Yes, on the module it already stick the drawing, yes, for easy to understand, but I just explain more and draft to this drawing. Okay, so totally we have 20 terminals, yes, the same as digital input also. And for terminal number 1 we can supply AC or DC. Yes, example, if we can use the this command AC or DC to control the relay. We can connect for the AC to DC. Okay. And for terminal number 10, we can connect 24 voltage minus or 0 volt DC to supply the module. And for terminal 20, we can supply 24 voltage plus to the module. Okay. So terminal number 10 and terminal number 20 is 24 voltage. Yes. And for terminal number 1 and number 11, we can use AC or DC to match with our plan. Yes. Example, we can control the relay or contactor with AC. We can connect AC. And if we would like to control the relay or some electrical devices with DC, we can use DC to connect the terminal number 1 or terminal number 11. Okay. So here is just example Q 0.0. We can connect from terminal number 2 to coil of relay. Number 3 to coil of relay also. And terminal number 4 to coil the relay also. Okay. Example relay, coil relay is used 24 voltage. We can supply this one for DC. And example relay use 220 volt AC. We can supply 220 volt AC to terminal number 1 and number 11. Okay. So totally we have 16 bits also. So we can use for relay number 1 until relay number 16. Yes. Okay, so here just draft the drawing for easy to understand. So to configure the program or add the hardware configuration with software, let's go to our software. Yes. So first open Schematic Manager. Yes. Version 5.6 or other version that we use. So I will use the existing project that we already learned in the previous video. So let's go to hardware and double click to hardware. So in the previous video we already learned how to add analog input, analog output and digital input. So right now we will add the digital output module for this CPU also. So before add, let's remember the serial number or module number. So 332-18801, right? So let's go to Schematic 300 and let's go to SM300 and let's go to DO. So 322-188, right? So let's go scroll to find it. So this one, let's see here is the model number or serial number. So we can drag and drop this module to the rack. Yes. And the address will start from Q12.0 until 13.7. Okay, totally 16 bits also. Yes. So we will save the project and then we will download to the CPU. Yes. Before download, make sure we check our computer. Yes. Make the manual mode for IP address. Yes. With 192.168.0. something. but not 1, because the .1 is the address of PLC. Okay, and we can ping after we connect the LAN cable from our computer to the part of the CPU. So we can use command ping 192.168.0.1. Yes, if it reply like this, it means that we can communication between our PC to the PLC. So we can download by push this button. Yes, and then OK, and wait a moment for our PC will detach. Yes, automatically detach with the CPU that we already connected the LAN cable from our PC to the PLC. So wait a moment for this connecting. Yes, actually we can wait around 10 or 12 seconds. Yes, so right now it found one CPU 314C 2PN/DP S7-300. Yes, so we can click view to view the node. Yes, okay, and then we can click OK. Yes, and if I push button OK, it will stop the CPU. Yes, I will show. So let's see, right now the CPU is start running. Yes, and if I push OK, it will stop, and then click OK, yes again, it will start. Yes, okay. So right now the CPU is starting, so and we can test with the digital output. Yes, but remember it will start from 12.0 and earn 13.7. Okay, so to test with the digital output, let's go to PLC and then go to the monitor, modify variables. Yes, and it will start from Q 12.0, right? Q 12.1 until Q 13.7, right? Okay, and I will zoom a little bit. Yes, zoom in a little bit, and then we can monitor. Yes, by push this button, and then we can force the signal also by, if I push this one. Yes, I will show. Yes, and then I will pull this one. Let's see, the output is turned on, and the volt of multimeter is show also. Yes, if I would like to push this one, yeah, for this one, I can write one, and then I push. Yes, this one also. Yes, one. Yes, it turned on, right? It earn of the bit number 16. Yes, turn on. Okay, so if we would like to remove force, we can 0, and then we can push this one also 0. Yes, 0 also. Okay, so it will turn off. Okay, so we can also write a program for test. Yes, yes, so let's go to OB1 existing program. So we can add one more network for test, Example, I will use the existing button, yes, start and stop, yes, and I will control the output, yeah. Example, two output, yes, like this, and I will hold the signal also, yes. Example, I will start from Q 12.0 and one more for Q 13.7, yes, like this, and I will hold signal by this one, yes, okay. So we can write some command. Example, this one, digital output bit 0, yes, and this one we can also comment digital output bit 16, yes, okay. So we can save and then download to the CPU, and then we can monitor, yes, okay. So if I push I 8.0, I 8.1, yes, it will let the Q 12.0 and 13.7 is turned on also, okay. So let's test, and this one is turned on and off also, the existing program, yes. So let me show, yes. So if I push button start, let's see, the point is turned on, yes, stop, start again, yes, stop again, yes, start again, yes. The existing point is turned on also, yes. So this is just example how to add, config and test the digital output module of PLC S7-300, okay. So I hope this video is useful for everyone, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. And I'm also sorry if I have mistake in this video because my English is not so good. And in this time I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to connect the PT100 or RTD to the PLC S7-300 directly to the analog input module SM331 7KF02 0AB0, okay. And here is the module, yes, that I already take it to explain to everyone, yes. So first we need to select to the A, B, C or D that we want, Okay. So in this section, we need to select to A because we use with the PT100. Yes. If everyone would like to use 0 to 5 volt or 1 to 5 volt or 0 to 10 volt of input, we can select option B. Yes. We can rotate from this one to like this. This is a selection. Yes. So if everyone would like to use the current for wires, we can select to C. Yes. So we can rotate the C to here. Yes. And the last one, if we would like to use the 2 wires current, we can select to option D. Okay. So we can rotate D to here. Yes. So it's very important for hardware selection, and if we select incorrect, so it will doesn't work correctly. Okay, and I will connect this module with the PT100 and connect with the rack of the PLC S7-300 CPU 314C to PN/DP. Okay, and connect with the LAN cable to the Schematic Manager version 5.6 and WinCC Flexible 2008 CV page 5. Okay, so this is a select the hardware, and it's very important for wiring the cable. Yeah, let me show the wiring. Okay, so this is a terminal. Yeah, there are 20 terminals of this module. So terminal number 1, we will connect the 24 voltage DC for supply, and terminal number 20, we can connect the 0 volt to supply. Okay, so we need to supply 24 volt to the module, otherwise it will not work. Okay, so the next step, we will explain about how to connect the cable or connect from the PT100 to the terminal of the PLC module. So for PT100, mostly we use 3 wires or 4 wires. Yes. In this section, I will use 4 wires. Yes, for connection. So we can use the terminal number 2 and number 4 is jumping. It means that we connect together. And terminal number 3 and number 5, we connect the cable together. So for number 2 or number 3, we measure the ohm. We can got around 115 something if the temperature around 30 or 29 something. Yes, and this is the address of the PLC. Yes, let me show after I explain this drawing. So for channel number 2, we can connect terminal number 6 and number 8 together, and number 7 and number 9 connect together between the sensor. Yes, and for channel number 3, we can jumping the terminal number 12 and number 13, 14, number 13 and number 15, and the last one for channel number 4, we can connect terminal 16 with the terminal 18 and terminal 17 with terminal 19. Okay, so it's very important for the wiring. So if we cannot wiring, we cannot transfer the raw data from the PT100 to the PLC module. Okay, so we cannot got the raw data if we cannot wiring the connection. Okay, So the first one, we need to use the selection, the hardware of the PLC of this module. And the second one, we need to wiring. Yes, how to know the wiring. Okay. So the third one, we can go to the software SIMATIC Manager version 5.6, and then create the new project. Before create the new project, I will create the new folder. Example, PLC S7-300 PT100. Yes. And so let's go to new project and then create the new project. Example, PT100, and browse. Yes. To find the folder that we already created. Yes. So let's go to browse PT100 here. Yes, and click OK and click OK again. And we will create the rack. Yeah. So right click, create the Schematic S7-300 station, and go to hardware and go to hardware configuration and create the rail. Yes, so go to Schematic 300 and then go to rail. Yes, here drag and drop the rail to here and then go to decrease. Yes, and then go to the CPU. Yes, the first one we need to use the power supply. Yes, example 10 amp, and then we will add the CPU. So right now I will use CPU 314C 2PN/DP, this one. Yes, so drag and drop to here to rail and then go to this is a default IP address of the PLC. Yes, so click OK first and it will appear. Yes, the IO. Yes, on board of this CPU. Okay, and then we not use this slot or this IO, so we need to add one more IO for the analog input module, right? So let's go to the SM. Yes, go to SM300 and then go to AI 300 and to find the module. Yes, that we will use. So 3317K F02. Yeah, this one. So drag and drop here. Yes, and then double click for configure the software. Yeah, before downloading. So the first one, this is a address, default address. So it will start from PIW 256. Yeah, and for the input selection, we will select use the PT100, right? So let's select to the RT and then select to the standard. Yeah, PT100 standard for all channel. Yes. Okay. Number 1, number 2, and number 3, and number 4. Yes. Okay, so make sure we select RT and then PT100 standard. Yeah, for all channel. And then we will click OK, and then we will save the project and then go to the ping. Yes, to check our computer with the PLC. So right now I already connect the LAN cable from my PC to the PLC CPU. So we can go to command prompt and then ping 192.168.0.1. Yes. So if it's so like this, it means that we can communication between our PC to the PLC. Okay. So we can make download configuration by push this button, download to module, and then go to select all and then click OK, and wait a moment for this configuration, because the computer will find automatically to detect with the PLC, yes, that we connect via LAN cable. So wait a moment for this detection, yes. It will found automatically if we detect the CPU, yes. Okay, so right now it already detect one CPU that has address 192.168.0.1. So we can click view, yes, and we can click OK, yes, and then right now the PLC is running. So if we click OK, it will stop the CPU. Yeah, let me show. Let's see here. Right now the CPU is running. So if we push the OK button, OK, it will stop the CPU, yes, for downloading. And then if we click yes again, the CPU will restart. Okay. So right now the CPU is already start, yes. Then we will check, because I already connected the PT100 to the module, yes. So let's check the address PIW256, yeah. Let's go to block here, and then go to PLC, and then go to monitor modify, yeah. So PIW 256, yes. PIW 258, sorry, 260, PIW 264, and PIW 268. Okay, and we can online for check and go to decimal, yes. So right now the PT100 of channel number 1, number 2, and number 3 is show the value raw data, yes. And for the channel number 4, I'm not connect the PT100 to the channel, so it will show maximum value, yes. So if we would like to calculate this one to the real, it means that to the actual value of temperature, so we can divide this one by 10. So it for channel number 1 around 30.3, channel number 2 around 35.0, and channel number 3 around 26.1. Okay, for channel number 4, I'm not yet connected to the PT100, so it maximum value, yes. So this is how to connect and select or configuration the software and hardware to PLC and connect the PT100. Okay. So the next I will show how to convert from this raw data to the actual temperature. Yes. So let's go to OB1, and I will use the ladder. Yes. For example, this one sensor number 1. Okay. PT100. Okay. So first we need to convert from PIW integer, right, to real, yes. So I will use the convert from double integer, integer to double integer, yes, and from double integer to real, yes, and then divide by 10, right? So divide by 10, so div real, divide real, and we will got the actual temperature for channel number 1. Okay, so here PIW 256, right? Channel number 1. And then for this one, I will use the temp. It means that the variable for convert this signal, because I'm don't like to use the some memory, yes. So I can use the variable. Example temp1. It is the double integer, right? So dint. So here I can use temp1, yes. Okay. And for this one, I can use temp2. It is the real value, right? So real data type. So I can use temp2 here, and then can copy and then paste here and divide by 10.0. Okay, and I will got the memory, yeah, the actual temperature. Example MD0. Okay, MD0. Okay, so we can download and we can online, yes. So right now we got the actual temperature around 30.3, right? Okay. So for channel number 2, we do the same, this format, yeah. So I will create one more network. So we will convert from integer to double integer, yes. So we can copy, yes. So this one should be 260, right? And then this one should be 10.3. Yeah, it is double integer. So 10.3, and this one should be 10.4. It is the real, right? So real. Okay. So 10.4, it is the real, and divide by Control C and Control V. So this one divide by 10 also, right? So it will got MD4 example. Okay, and then we can download, and we will got the actual temperature for channel number 2, right? Around 35.2, yes. And for channel number 3 and number 4, we can do the same, yeah. So here we can comment number 2 for PT100, and we can copy and we can insert, and we can paste for channel number 3, yes. And then we can copy, paste, copy, paste, copy, paste, and we rename this one to PIW 263, yes. Okay, and this one should be temp file, right? So temp file, and it is the double integer, so dint temp file. You can copy and then paste here because the same variable. And for this one we can use temp6. It is the real, right? So real. Okay, temp file, and this one temp file also. Sorry, temp6. This temp6. Okay, and divide by 10. So we will got MD6. Sorry, MD8. Yes. And for channel number 4, we do the same, but we not yet connect the PT100 to the module, so no need to create. Yes. See. So this one, we got the actual temperature around 26.3 degrees Celsius. Yes. And for channel number 2, around 35.4 degrees Celsius. And for channel number 1, around 30.5 degrees Celsius. Okay, so this is how to convert the raw value to the actual temperature, and then we will show this value to the HMI also. So let's go to WinCC. Yes, go to WinCC Flexible to create a new screen. Yes, so go to create the empty project, and then go to the schematic. Yes, screen. Yes, so right now I will use TP. Yes, 177B 6 color. Yes. Okay, and then I will use create one more connection. Yes. Okay, example connection 1, connect with the PLC 300 or 400 S7, and then I will choose internet. Yeah, and this is the IP address of computer. So my computer is IP config 192.168.2 sorry .0.253. Yes, so 192.168.0.253. okay, and then here is the PL3 address. Yes, so 192.168.0.1. okay, and we can comment here connect HMI to RTD or PT100. okay, and then go to create the text. Yes, so the first one is the text for channel number 1, right? So this one. So example PT1 100 underscore 1, it means that sensor number 1, and it is the real. Real start from MD 0. Yes, and we can comment sensor number 1. Number 2, yes, MD4 real also, and sensor number 2. and for PT100 number 3 is the real also, and sensor number 3 for command. Okay, then we can create the screen. Yes, so first I will change the color to be the background to another color that I want. Example, I would like to use this color. Yes, and then I will use label. Yes, example, sensor 1. Yes, PT100. Okay, and I will use the color. Yes, change to another color. Example, color yellow, and I will change the font to be bold, Takuma bold, around 14, and I will use center and then use middle. Yes, for sensor number 1. Okay, and then I can use the IO file for show the raw, show the actual value. Yes, so it is the output, right? And then go to the center for font, text, and then middle, and we can change this one to be 14. Yes, and it not reach to 100 degrees C, right? So I change this one to be like this, and then we can resize. Yes, this one, and then go to the color. So I will use the green color for text, and the background I will use black. Yes, and for the unit is the degree Celsius, right? So I can copy this one and then write like this. Yes, and one more, we can use this one. Yes, see. Yes, like this, and we can copy to sensor more. Yes, like this and like this. Okay, so we can align it. Yes, like this. Copy this one more and this one more. Yes, for title we can write something. Example, actual sensor PT100. Yes, and we can use another color that we want, or we can resize to be 16. Yes, example, and I will use the another color. Yes, example, this color or this color. Yes, so the next step we will create the text, right? So go to here, process text, and go to the PT100 number 1. Yes, this one also PT100 number 2, and this one PT100 number 3. Okay, and this one I would like to change a little bit more about the background. Example, this one should be changed to, sorry, the style solid, I will change to this one. Yeah, this color. Good. Okay. So we can simulation. Yes. After we create the screen. Okay. So wait a moment for start simulation. Yes. Okay, so right now it show around 30.9 degrees Celsius for channel number 1 here. Channel number 2 around 35.7 degrees Celsius. And for number 3 around 26 something. Yeah, 26.5 degrees Celsius. Okay, because I already connected the cable to the channel number 1, number 2 and number 3, and for channel number 4 is spare. So in the next video I will show how to connect one more TC. It means that connect one more thermocouple to channel number 4. Okay, so this is how to hardware configuration, how to wiring, and how to configure the software, and how to convert from raw data to the actual of PT100 with actual temperature. Yes. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also, to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again, and I'm also sorry if I have mistake in this video, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to connect the PT100 or TC to PLC S7-300, module SM331 7KF020AB0. Okay, and I will use Schematic Manager and WinCC Flexible to software configuration to CPU 314C2PN/DP. Okay, and here is the previous video that we already learned about how to connect the PT100 3 sensors to the PLC this module. Yes, and today we will continue to connect one more TC. It means that thermocouple to the channel number 4. Yeah, this one. For channel number 1, number 2 and number 3, we already connected the PT100. Yes. So we will add more for TC. Yes, to the channel number 4, and then let create the screen for show the actual temperature also. Okay, so before go to our software, I would like to show and share about how to wiring the TC, yes, to the terminal of PLC S7-300 this module. Okay, so let's go. So for PT100 wiring, I already explained in the previous video. So in this section, I just add one more for thermocouple. Yes, and we will use the terminal 16 for positive and terminal 17 for negative. Okay, and this is a millivolt that detect from the thermocouple and send the signal to the PLC. Okay, and here is the address PIW26X that we will use for config inside the software. Okay, so we need to wiring, yes, before we config the software. Okay, so let's go to our software to create the block or configuration the hardware. Yes, so let's open the existing project that we already learned in the previous video. Yes, so let's open, and then I will find the project. Yes, the existing project we use PT100, so let's open, and first go to hardware and go to the module. Yes, so for address I will keep default, but the input, this is a previous video, so I will change the input number 6 and 7 or channel number 4 to TC. Yes, and then I will use type K for connect from thermocouple to the terminal of PLC. Okay, so we just change like this. Yes, and then let OK, and then we can save and then download to the PLC. Yes, software configuration is very important. If we select not correct, so we cannot got the raw data from the thermocouple. Okay, so it's very important. So wait a moment for connecting between our PC to the PLC. Okay, so wait a moment. So right now it detects the CPU, so we can download. Yes, okay, download successfully, and then let's go to our block. Yes, open the OB1 that we already learned in the previous video. So in this one we can copy from the text. Yeah, and I will insert the new network, and this is a PT100, but now I will change to TC or thermocouple for channel number 4. Yes, and basically we can use convert from the integer to the Boolean integer, so integer to di. Yes, so this one should be a PIW26H. Yes, because hardware configuration we already set this address. Yes, and then I will choose insert one variable called temp. Yes, we can use temp7. Okay, so temp7 is integer to the Boolean integer, right? So we can write dint for the Boolean integer, and then here is temp7. Yes, here, and I will use the Boolean integer to real, right? Can copy from here, paste, and then I will choose one more for temp8. and it will be real, yes, for data type. So temp H, okay, and we will divide by 10, right? So divide real, so temp H divide by 10.0 and MD 12, right? Okay, and then we can save the project and then download to the PLC, and we can online, yes. So right now it show around 26 degrees Celsius, yeah, for this sensor. Okay, so we can go to the WinCC Flexible to create the screen more, yes, for show the actual. Okay, so let's open the existing project for WinCC Flexible. Okay, the project is PT100, yes, and then we can go to add the new text, right? So we can go to the text, create the new text. This one for TC one, right? And it is the real, and this automatically created for MD12, the same as the PLC that we already created. So this one thermocouple one, okay, thermocouple one. So here we can copy from here, yes, drag and drop, just drag and drop, and then we can change this one to PT 101, yes, this one should be PT 102 in the previous video, right? And this one should be PT 103, and the last one for TC, right, that we already created, TC1. Okay, I will adjust to be like this. Okay, so we need to configure the text, yes. So TC, the text that we already just created, yes, and we can save, and then we can simulation, yes. Okay, let's see here. Right now it show around 25.4 for TC, right? So it's very easy for create the block of the PT100 and TC. We just convert from integer to real and then divide by 10. Okay, so we can got the actual temperature, yes, from those sensor. Okay, and in this case, if we take out the one cable, I mean that when we take out the one core of thermocouple, it will show maximum. Okay, so if everyone have any question, please kindly drop comment under my video. I will reply soon, and I'm also sorry if I have mistake in this video also, and I would like to request all of you to like, share, and subscribe my video also. to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use function that we call library FC105 scaling analog for use to connect with the generator, example phase ABC voltage, speed sensor number 1, number 2 and number 3, frequency, current, something. So we can use the function FC105 for scale the analog. Okay. And in this section, I will use PLC S7-300 CPU 314C 2PN/DP and connect with the external module analog SM311 7KF02 0AB0. Okay, and I will use two softwares for testing and simulation. The first one is SIMATIC Manager version 5.6 and the second one is WinCC Flexible 2008 SP4. Okay, so let's go to our software to create the program. But before go to create the program for function block, or we call library FC105, I would like to explain the concept a little bit. Okay, so for generator, for example, we have the voltage, measure the speed sensor, right? Example, we have 3 positions, so we can install the sensor for 3 position. Okay, and the sensor will generate the current 4 to 20 milliamp to the PLC S7-300. Okay, and also we must measure the frequency, yes, and current also. Okay, so this is just example or concept of generator. And for measure this point, we must create the program for convert from the analog to show the raw or the actual value, example the RPM or show the volt. Okay, so let's go to our software to create the new project and use the FC105 to scaling. Okay, so let's go. Okay, so first we need to create the new project, and before create the new project we need to create the new folder, example generator. Okay, and the first one we need to open the SIMATIC Manager. Okay, okay, and then create the new project, so file, new project, or we can click here, yes, and we can write generator and browse to find the folder that we already created on desktop called generator folder, and then click OK and OK. Okay, and the next step we need to create the hardware configuration, so need to create the object. So I will use Schematic 300 station and then go to hardware configuration. Yes. So let's go to Schematic 300 and then go to add the rack. Yes, go to the rack 300 and then drag and drop the rail to the project. Okay, and then we will got the rack of PLC S7-300 11 slot. Yes, and then so we need to create the power supply for this rack. Yeah, to supply the voltage to the CPU and I/O module. And then we need to create the CPU. Yeah, insert the CPU. And the CPU I will use 314C 2PN/DP. Yes. And version 3.3. So we can drag and drop to the rack. Okay. And this one is the IP address, default IP address of the CPU. So 192.168.0.1. Yes, and then click OK. And we will got the I/O for the default I/O. Yes, module that built in on the CPU. Okay. And then we need to create one more for external analog input module, right, to the rack. So go to SM300 and then go to AI, it means that analog input, and find the serial number to match with the hardware module. So right now I will use 331-7KF02 0AB0. It related to the module, hardware module. Yes, here. And then drag and drop to the rack. Okay, here. And the next step is very important for this module because we need to select the hardware to be the same as the software. Otherwise, when we download to the CPU, it will show the fault. Yes. Example, right now I will download. Yes, but no need to adjust anything or select to change anything. So let me show. It will error when we download to the module. Okay. So right now, before go to download, first we need to know about the IP address of PLC, right? In the previous step, I already showed its IP address of PLC is 192.168.0.1. Okay. Then we need to know the IP address of PC. It means that our computer. So we need to put the manual for Ethernet module because right now I connected the LAN cable from my PC to the PLC. Okay. So let's go to put the manual mode by right click here, open network and sharing center, go to local area connection and then go to property and go to the internal protocol version 4, yeah, IP4, and then click property. Yes. So in this step, if everyone not select example here, actually it like this. So when we open first time, yeah, it will automatic for IP address, right? So we need to put the IP address to the same as the rank of the PLC, right? So it should be 192.168.0. Something, but not yet, not dot one. Okay, so example not dot one, I will set dot 253. Yeah, and for subnegmat it will be 255.255.255.0 because it class C, right? And then click OK, OK again, and then click close. So IP address of PC is 192.168.0.253. Okay, and we can ping, yeah, by press Windows plus R, yes, and write the CMD. So we can ping 192.168.0.1 because it is the PLC IP address, right here, and then press enter. Yes, so it's so like this. It means that we can communication between our PC to the PLC. Okay, and then if everyone would like to ping every time, we can use the .t. Yes, it will ping every time. Yes. So right now, let me save the project and then go to download, because we already connect the LAN cable to the PLC, and then we can connect also. Okay. So to download the hardware configuration to the CPU, let's go to download, click download one, and then click the select all, and then click OK. And wait a moment for detecting. It will automatically detect the CPU because right now we already connected the LAN cable from our PC to the PLC, and we also can ping, yes, here. So wait a moment for automatically detect with the PLC, yes. Okay, so right now it detects one CPU, yeah. Here is the IP address, and here is the module type, yes. Station name, yes. And module name, okay. So we can click OK to download, and it will show false because right now I select the hardware, yes. The hardware of the external module right now for channel number 1 I select to C, it means that for Y current. Channel number 2 also to C, but channel number 5 and number 6 I select to A, it means that PT100 or thermocouple, yes, and channel number 6 also. But the actual that we download is select to default, right? Because right now I want to test the false signal to everyone. Otherwise, if everyone have fault, the system fault on the module, everyone can trouble it. Okay, so if I click OK and then start the CPU, the CPU is full right now, yes, because we not yet select the input, yes, input type, so it will fall. So right now we need to select the input to follow our selection on hardware. So channel number 1 and number 2 we will select to current, yes, for Y. Okay, so let's go here and then select input, and channel, this channel I will select to current input for Y, yes, for to 20 milliamp, and for channel number 2, right, it will for Y current also, so I will select to current for Y, but channel number 4 and number 6, sorry, number 5 and number 6, I will select to PT100 and thermocouple, right? So right now for this channel I connect PT100, and for this channel I connect thermocouple. So both of channel we can select to A. Okay, so here I will select to thermocouple, yes. Okay, standard PT100, and this one I will connect to TC type K, yes. So that's correct, and then save the project again, and this one also it full. So right now I will use current for 220 milliamp, current for 220 milliamp, current for 220 milliamp, and one more current for 220 milliamp also. Okay, and for this one I will select standard, okay, PT100, yes, because right now I already connected the cable to this channel also for PT100. Okay, so let's click OK and then save project again, and then download again by press button download, and then press OK. So right now we no need to wait because it already detect to the PLC, and then click OK and we stop again, and then click yes to run the CPU, yes. So right now we already insert or configure the hardware configuration. So for the next step we need to use the FC105 to create the scaling, right, for show the voltage, phase A, B, C, sensor number 1, number 2, and number 3, frequency and current of generator. Okay, so let's go. Okay, I will minimize this one and close this one. So first go to Schematic and then go to blocks. Okay, so we can go to the OB1, double click to OB1, and then we can comment on the network, example voltage phase A of generator, yes, and we will use the FC105, right, from the library. So go to library and then go to standard library, and then go to TI S7 converting blocks. Okay, and then scroll to find the FC105 scale convert, and then drag and drop to the network 1, yes, we will got like this. Okay, so we can use the first address because we use the voltage phase A, right? So we need to go to hardware. Okay, this one. It will start from PIW 800, right? So example PIW 800. Okay, and we can also edit the symbol. Yes, and the data type is integer. Example voltage. Example phase A. Voltage. Okay, like this. And for voltage, I will set the high from 0 to 400 volt. Yes, so this one 0 to 100 voltage. And for this one, we can use another address that we want. Example M0.0. And for this one, we can use another address that we want. If everyone not clear, we can press here and then press F1. So we can assign the address that we want like this. Example MW 0. Okay. And this one example MD 100. Yes. And we can save and then we can download and then we can online to check. So right now it show around 99 volts because I already connect the standard source for simulation, connect the milliamp to the channel. If I adjust, yeah, let's see here, it will up 20 milliamp. It will show around 399, yes, 399 volts. Okay. So we need to use the phase B, yeah, the same as this one. So we can insert the new network, yeah, drag and drop here. Okay. And then it will start from PIW 802, right? Because PIW 800 we already use on phase A. Okay. So this one we can copy and then paste. Change this one to B. Okay. And for this one 400.0 0.0 M0.1. Example MW 4 MD 104. Yes. Okay. And this one we can edit the symbol. Data type is integer, and for phase B, voltage phase B. Yes. Or we can command the same like this. Phase B voltage. Okay. Okay. And we can insert new network and we can copy this one. Yes. Paste 804, right? And we can edit the symbol to be integer for data type and phase C voltage. Okay. And the scale is the same, but I will change this one to M0.2, MWH, MD100H, and this one I will copy this one to pass for phase C. Okay, and you can save and then download to the PLC and we can online to see. Okay, so right now let's see, because I connect the current to the same channel. Yes, because right now let's see here the value is the same. Okay, so the continue to this step, we will use the PIW 806 to show the current, right? So let me show. So we can insert, copy this one to here, and we can command current of generator. So I will use PIW 806. So we can edit the symbol to be integer and then current of generator. Okay, for current the generator, I will change the scale from 0 to example 150 M. Yes, and this one I will change to M0.3, and this one should be 12, 112. Okay, and the next step I will copy and then insert the new network for frequency, right? So frequency of generator, okay, frequency of generator. Then I will use the channel number 1 of this card. Yes, because this one we can use only 4 channels, right? Because it is the RTD. Okay, so I will start from PIW 5256. Yes. Okay, so PIW 256, it is the frequency, right? So frequency integer also, frequency of generator. Okay, and for frequency I will use around 60 Hertz, because if we set only 50 Hertz, it will maximum, because it can increase over 50 Hertz. Right now I will set 60. Yes, and this one change to M0.4. And for this one I will increase to 16, MW16, MD116. Okay, so for voltage and current and frequency of generator we already create. Okay, so we can save the project, and in the next step we will create the speed and temperature of bearing, right? So I will create the speed. Yes, For speed is 3 position. Yes, this one speed sensor number 1. Okay, so I will start from PIW 258, the channel number 2 of this card, right? This one. Yes. So PIW 258. Okay, and we can edit integer also. So speed sensor number 1. Okay, and for speed the generator right now around 3000. Yes, and this one I will change to 0.5 M0.5. Yes, this one I will change to MW20 MD 120. And for speed number 2, I can right click, copy, and then insert the new network and then paste. And we can copy and paste this one, change to speed number 2, and this one should be 260. Yes, edit the symbol. It is integer also, and I will comment speed sensor number 2. Okay, and the scaling is the same, 0 to 3000 rpm. This one I will change to M0.6. Okay, and this one should be MW24 MD 124. And for speed number 3, we can copy from here and then insert the new network and then paste, copy this one, and then number 3, right? And I will use the PIW 262. Yes. Okay, and we will comment, yes, speed sensor number 3. Scale is the same, but I change this one to M0.7, and this one 28 MW28 MD 128. Yes, and we can save. Yes, and we have three more for temp bearing and temperature winding of generator also. Okay, so I will insert new network. Okay, so we can add more for temperature, but the temperature for bearing of generator and winding, we no need to use this one. I mean that we no need to use FC 105. Yes, so this one we can comment of bearing of bearing of earn bearing or heat bearing. So we need to convert from integer to double integer, right? So we can use the integer to double integer, yes. And then I will use this one, yes, yes. The last one of the internal module, yes. So it will PIW 808, right? And then we can comment, yes. Temperature of head bearing. Okay. And then for this one, I will use the temporary variables. Okay, I will create new for example temp1, or we can write var1 value1, yes. And the data type is double integer, right, here. So dint, okay. So this one should be var1. And I will convert from double integer to real, right? So di to real, yes, this one. So this one should be copy and then paste here. And then I will insert one more for temp, example var2, and the data type is real, right, here, double integer to real. So real, so var2, okay. And then I will divide this one by 10, because in the previous video we already learned about how to connect the PT100 to the PLC S7-300 module, yes. And then I will divide real, yes. So I will divide this one by 10.0, and then I will show MD, yes, 120/32, right? Because here we already used the 128, yes, plus 4, yes. Okay, and then I will create one more network for earn bearing temperature. So we can copy, paste, copy, paste, copy, and paste, because it's the same procedure, right? So this one I will use, yeah. This one is, that's all, right, for file channel. So for this temperature, I will start from the PIW 264, yes, because here we just use 262, and then here I will use PIW 264, yes. And then we can use the integer and then comment temperature temperature earn bearing Okay, and this one I need to convert from integer to double integer, right? So example var3, and the data type is double integer dint. Yes, so var3, and I will copy var3 and paste here, and this one double integer to real, right? So var4, and the data type is real. Okay, so var4, copy var4 and then divide by 10 also, and this one for show the actual. Yes, then 36, right? 136. And the last one for the temperature of winding, it means that we can check also for the coil inside the generator. Yes, so we can copy from here, temperature of winding coil. Okay, so I can copy P, Control C, Control V, Control C, Control V. Yes, and then I will use the PIW 268, right? Because it is the last one. Let's check here. PIW 260, PIW 262, PIW 264, and then PIW 266, right? Because 266 we cannot use. It used for 264 and 266. So this one should be PIW 268, right? And we can remark integer also. This one temperature winding of coil, and convert also. So var5, it is dint. So var5 here. Let me control Z, control Y. Yes, var5 double integer, right? So var5, and this one PIW 268. Then I will copy var5 to here and insert one more for var6. It is the real, right? So this one should be var6. Copy var6, paste here, divide by 10, and then the result is 140. Okay. So that's all for create the block of temperature and voltage and frequency, current, and also temperature of bearing and winding. Okay, so let's save our project and then download to the PLC, and we can online. Yes, so it show around 36, 25 something. Yes. Okay, so we need to show this one to the HMI, right? So we will create a new project of HMI also. So let's go to WinCC Flexible here. Double click and then create a new project of WinCC Flexible. Okay, create an empty project and then choose the touch panel that match with our hardware. Yes. So right now I will use TP177B 6-inch color PN/DP. Yes. And the next step we need to create the connection, right? So example connection 1 I will rename to HMI1, and the driver communication is connected to Schematic S7-300 400, right? It many brand that we can use. Example GE Fanac, LG, Mitsubishi, Omron. Yes. So right now I use the S7-300 400. Yes. So click here. Connection of generator HMI. Yes. And don't forget choose the Ethernet. Yes, because right now we will simulation by using the LAN cable. So here the IP address of our computer, right? So 192.168.0.253. Okay, 192.168.0.253. Okay, and here is the IP address of PLC module. So 192.168.0.1. Yes, 192.168.0.1. Yes. Okay. And then we will create the screen. Yes. So let's go to the symbol. Okay. Go to the motor to create the symbol, right? Okay, go to motor here, and I will use this one. Yes, it's similar to be a generator right now here. Let's see. Okay, and we can use the text. Okay, go to the text file. Example generator of turbine. Yes. Then we can increase the font. Okay, I will change the background of screen to be this color, and change this one to be 10. Okay, Tacoma 14. Yes. Okay, like this. And then I will change the color to be this color. Okay, good. Adjust this one a little bit. Yes, like this. Okay, to center. Actually we can resize. Yes, this one also by using this one. Yes. Okay, and then we need to show the voltage of phase A, B, C, right? So we need to create the text. Let's go to the text tab. So this one should be volt A. Yes, volt phase A. It is the real, right? And what is the address? MD100. So MD100, okay, will be, okay, change this one to be 104, okay, automatically, and we can command, actually we can command here, example, voltage phase A, copies, paste, voltage phase B, volt C, it means that voltage phase C, yes, paste here, okay, 100 H, 100, 104, 100 H, yes. Be careful if we put the address here incorrect, it also incorrect here, right? So the next step we need to create the current, right? So MD 112, so current 112 current of generator. The next step is frequency. Okay, let's check the address. Frequency is MD116. Okay, the next step is speed sensor. MD112 120. So speed sensor, example speed 1, yes, frequency, okay, speed, position number 1, speed 2, speed position number 2, okay, and how about speed 3? 128, right? So speed 3, can pay this one, okay, and one more for temperature of heat bearing, right? So temp heat, what is the address? So MD132, right? 132, okay, so heat bearing, temperature, the next temperature of urn bearing, right? So we can copy and then paste here, just change this one to urn bearing. And the last one is temp winding, right? So winding temp winding, okay, temperature of winding, okay. So that's all for creating the text. So we need to create the screen, right? So I will go to IO files, create the platform, and then copy and paste, yes. So this one just output, and should be this format, yes, or this format. And let's go to property, go to the text. I will change this one to 12 and then center, middle, and let's change the property to text color should be green. This one should be black. Yes. And also has the solid. Yes. Example white. Yes. To be a cover. This one. Okay. So I will copy. Example this one voltage phase A. So phase A. Okay, like this. So change to center and then change to middle. Okay, and then change color to be yellow. Yes. Okay, phase A here. Then we can arrange to be good looking. Yes, like this. Phase B, just change this one to phase B. And then phase C also, change this one. Drag and drop for copy. Okay, change this one to phase C. And for the unit, we need to create the wall, right? For unit way. Okay. Or we can change to the white color. Clearly white color. Yes. Okay, wall also. Okay. And then we can change this one to output also, and then volt A, right? Voltage phase A here. This one voltage phase B, and this one voltage phase C, right? Okay. And then we can save the project to a generator. Okay. And then we can simulation. Yes, to test. Wait a moment for running simulation. Yes. Okay, so right now it shows around 200 and 199 volt. So if I adjust the milliamp, yes, let's see the voltage around 300 volts. Yes, for phase A, B, and C. And then we can add more for current and frequency. So I can copy and paste here. Example current we can put here. Okay, current. So we can put the tag for current. Yes. And the unit is M. Okay. And one more for frequency. Okay, so we can copy this one for unit of frequency. Yes, Control C, Control V, and for this one should be hertz, right? Okay, current, and this one for frequency around like this. Only one decimal. Yes, so this one should be a frequency here. Okay, and we need to show the speed sensor position also. Okay, so let me copy all like this. So speed sensor 1, sensor 2, and sensor 3, because speed is very important, yeah, for generator. And this one should be RPM. Yes, RPM. Yes, RPM also. And this one, speed sensor 1, yes. So I will change to speed 1. This one change to speed 2. And this one change to speed 3. And we must change the format. Yes, because for speed it 300, sorry, 3000, right? Okay, so I change the format to be like this. Okay, good, like this. And we have the speed, sorry, we have the temperature also, right? For heat bearing, earth bearing, and temperature of coil winding. Okay, so I will put here. I will use this format. Yes, example, I will put here for temp bearing, heat bearing. Yes, so we can use the heat bearing, and the unit is degree Celsius, right? Okay, degree Celsius. Okay, I will put here. And I will change to the yellow color. Yes, so this one heat bearing, and this one for earth bearing, temperature. Yes, copy and paste, drag to here. Okay, and change this one to earth bearing, and the last one for temperature of winding, right? So I will put here for temperature winding. And then copy this one and paste here. Okay, something like this. And then we can save the project and then simulation, yes, to see the condition. Okay, like this. So right now the condition show like this, yes. So I will increase the current, I mean that increase the milliamp to show to everyone, yes. Example, I will create the volt, yes. Okay, I will create the volt, yes. Maximum around 400 volt, yes. Decrease and increase here, yes. And I will increase the temperature also. Let me hit the temperature. Okay, it will increase, right? Okay. So this is just instruction about how to use the library to convert from the raw value to the real value of analog input that I already show in this video. Okay. So if everyone have the project to be similar like this, everyone can use the PLC S7-300 to use. It's easy to create because we have the library, yes, many library that built in inside the software. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone. Welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to create PID control of PLC S7-300 CPU 314C 2PN/DP. Okay. So what we need to do, we need to create the library of PID control, yes, and we will create the touchscreen for set point, see the PV, and check the output, right? and also adjust some parameters. Yes. So to create the program, I will use the SIMATIC Manager version 5.6 and WinCC Flexible 2008 SP5. Okay, and then we will download and connect to the PLC S7-300 via LAN cable. Okay, so let's go to our software. So here is the software SIMATIC Manager version 5.6, and this is a WinCC Flexible 2008 with page 5. Okay, so first we need to create the PID control on the SIMATIC Manager. Yes, so open it. Yes, and then create the new project. Yes. Okay, so to create the new project, let's create the folder first. Example PID control. Yes, PID control, and here is I can write PID control. Yes, PID control, and browse to the folder that we already created on the desktop. Yes, so PID control, yes, the folder, and then click OK, and let's create the object. Yes, S7-300 station. Yeah, so let's double click and then create the hardware configuration. So we will use the power supply first. Yeah, so go to rack, sorry, S7-300. Yeah, go to rack and then go to the real, and then go to PS. Yes, and then go to the CPU. So right now I will use CPU 314C 2PN/DP. Yes, version 3.3. So drag and drop, and then here is the IP address of the CPU. Yes, so let's click OK first, and then here is the address. Yes, automatically made because it built-in CPU. Example for digital input and output, this address start from I136 until I138. Yes, analog also start from AI 800 until AI 809. Yes, and this is analog output start from AI 800 until AI 803, right? And this is a counter, and this is the position. Yes, so what we need to use, we use only AI and AO. Okay, so first let's save our project and then download to the PLC. To download to the PLC, first go to set temporary. Yes, it means that set the PC interface. Yeah, and then click here. Yes, and then click diagnostic to test our connection. Right now I already connected the LAN cable from my PC to the PLC. Yes, we are port PN. Okay, so click OK, and then let's go to download. Yes, select all and then OK first. So wait a moment, it communication between our PC to the PLC. Yes, little bit. Yes, take time. Okay, right now it found one CPU 314C 2PN/DP. Okay, and this IP address. So actually we can also ping 192.168.0.1, right? Okay, like this. So we can ping from our PC to the PLC via this IP address. So click view, and then download. Yes, click OK, and then the CPU will stop and start again. Yes. Okay, so to create the PID block, first let's go to the block and then insert the new organization block. Yes. Example, I will choose the ladder language, and I will choose OB certified cycle block. Yes. Yes. And then let double click on this organization block. Yes. And then go to insert the PID control from the library. Yes. So let's go to library, standard library, and then go to the PID control. Yes. Okay. Normally I use FB41st for control. Yes, so drag and drop and then go here. Yes. Okay, so what we need to do here is we need to create the DB data block. Example DB 41st. Yes, and then click yes. Okay, and then the DB will create automatically. Yes, here you see. So here we can use the manual mode. Yes, to enable the manual mode, let's go to the manual mode. Yes, like this. By click example, we will use the NO, right? Example 0.0. Yes, and drag and drop to the main on. Yes, like this. And one more for deselect. Yes, you can also create the deselect by press here and then go to here. Yes, and I will use ANSI example M0.1, drag and drop. Yes, to the deselect. Yes. Okay. And actually in the GAN, yes, GAN TI, TD, yes, TM, we can use to manual from the HMI, yes. So we no need to create here, yes. SP in, yes, but the set point we will use from the HMI also. Example, set point from touch screen. So we can use the any memory. Example, AMD 100, yes, like this. And here is the PV. Actually, the PV is included on the DB 41st, yes. And here is the output, yes. We can create some value, yes, some variable. Example, AMD 102, yeah. Okay, or we can write 120, yes, like this. So we can save our project and then go to the create the scale, yes. Example, we use the set point from 0 to 10 bar. Example, the pressure 0 to 75 degrees for temperature. So we need to convert the analog input to the scale, right? So save our project and then go to OB1 block, yes, later also. So we need to create the scale, right? So let's go to insert the FC05 from the library, yes. FC S7 block, right? Converting, yes. So I will use this FC105 for scaling. Example, the address is start from AI, yes, PIW 80, sorry, PIW 800, yes. So here we can write PIW 800. And then example, it is the high scale, yeah. Example, 100 bar. This 0, yes. And here we can use another memory. Example M 100.0, yes. And here is the output, right? So we can use MW50, yes. And here is the output. Actually, the output is related to the dB, right? This dB, yes. So the PV, yes, let's see, the PV is start from dB 41st dot dbd 10, right? PV in, yes. So let's go to dB 41st dot dbd 10, right, for PV. Okay, so let's save the project, yes. Okay, so that's all for created the block of PID. So let's select all and then download to the PLC, yeah, by click download, stop, and then start again. And then let's go to OB1 for check the analog input, yes, come or not. Okay, so right now I will adjust the milliamp, yes. Okay, I will adjust. Okay, decrease, you see, when the maximum it will show 100 bar, right? Yes. Adjust the analog input, yes. Okay, so right now the analog input is okay, so let's go to OB certify, yes, and then like this. Okay, so actually we can online both block, yes. So right now the output is still 0, yes, because we not yet set point, yes. To create the set point and some parameter from the HMI. So let's go to our software WinCC Flexible, yes. So I minimize this one first, and then let's go to WinCC Flexible, yes, and then I will choose the new screen, yes. Yes, I will use the TP 177B 6" color, yes. So let's click OK. So first we need to create the connection, yes. Double click on connection, example PID control. Yeah, connect to S7-300, yes. Online on connection for HMI with PID, yes. Okay, and then I will use the internet, yeah, and here is the IP address of my computer example. So IP config. Okay, right now my PC is 192.168.0.253, yes. So 192.168.0.253, yes. And here is the IP address of the PLC. So 192.168.0.1, right? Okay. So we can simulate from the HMI from the PC without HMI. Yes. Okay. So click OK and then go to take, right? Okay, I will save the project first. Yeah, example PID screen PID HMI. Yes. PID HMI. Yes. Okay. And we need to create the tag, right? So first we need to create the set point, right? Set point value from the HMI, example 10 bar, 10 degrees Celsius, example. Okay. So we need to create the set point first. So to create the set point, let's create the variable. So set point PID, yes, and it is the real data type and start from MD, right? So MD 100, yes. MD 100. Okay. And the next we will create the PV, right? So it is the feedback, yes, or we can say PV. So let's go to check the box for the PV. So go here, DB 41st, yeah, and go to check the PV, right? So PV in, and the output, right? PV in, it is the out. So input we can use this one, yes. So it is the real, right? PV real also, and then here is the PV. So db1, sorry, db 41st dot dbd10, yes. db 41st dot dbd10, yes. Okay. And the next step we will create the gain, right? Here gain ti, td, and tm, right? So create the gain, yes. For gain we can use from here because we need to tune the PID, yes. db 41st dot dbd 20, right, for gain. So I will change this one to 20. Okay, and the next is the ti, right? So ti is 24. Okay, correct. The next is the td 28, right? And One more for TM take. TM leg, yes, 32, okay. So we can create the screen, yes, because we already created the text. So let's go to simple object. And then go to the text file, yes. Example PID control and monitoring. I will change the color, yes, to be blue color, yes, and adjust the font to be 18, yes, example 18. So big, so 14. Okay. So what we need to do, we need to create the PV, right? So SV first, set point first, also okay. So SP, it means that set point, yes. Change the color to be okay, yellow color, and then create the IO file, right? So set point is the input, right? So it is the format, example 999.9, yes, like this. And let's go to text. So SP, yes, set point PID. Let align to be center and then middle, yes. Okay, so we can copy from this part for feedback. Feedback, right? This is a set point. We can write set point. Yes. Set point feedback. So feedback is the output, right? Go to feedback, yes. And then we can copy, yes, drag and drop, copy. For gain, right? Gain. So gain is the input. Here is gain. And this one should be like this. Yes. And the next step should be TI, right? So TI. This one also take TI, right? TD. Yeah, TD. It is the millisec for TD, TI. Yes, TD. And the last one is T leg. Yes. So we need to monitor the output also, right? So the output, you see the block, right? Here is the output. Let's go to output. Okay, this one for output. So db for t first dot dvd 70 second. Yes. So need to create one more take, yeah, for output 70 second, right? Okay. So the last one is output, right? So it is the output. Should be like this. .99.9, yes. And it is the output. Yes. Okay, so let's align the text. Gain. Yes, align. Okay, so we can align left, right? Okay, good. So let's save the screen and then let simulation. Yes, simulation. Okay, so I will change the font to be bigger than this. Go to property, text, and then adjust to 15. Yes. Okay. So here example, we have the unit also. Example by, yes. And this is a feedback, yes. And this one example percent, yes. Output is percent. Control the VSD or some electrical devices. So let's test again. Okay, good. Okay. So right now I will set point to this one, yes. Example, I would like to set 50 bar, yes, 50 bars. You see here is 50, and then the PV is 82.3 bars, yes. So the PID is not yet working right now because we not yet adjust the gain TI, TD, yes. So example, I adjust gain to 2, TD example 1000, yes. $6,000 also, 2,000, yes. Let see, I will adjust the milliamp, yes, to let the PV is less than set point, yes. Less than set point. And we need to put the cycle time also, yes. So I will outline first and then go to put the cycle time. Example T 100 millisecond. Save and then download again. Yes. Okay, right now you see the PID is working, yes. If I adjust the output, adjust the PV, yes, less than set point, you see the output is go to 100%, yes, because the PV is less than set point. If I adjust the PV, yes, to be greater than the set point, it will the output will go to 0. Okay. Okay, if I adjust decrease again, so here we can tune, yes, the PID also. Example adjust to 4, yes. Yes, you see the output is start adjust. If we would like to fast or slow, yes, to control fast or slow, we can adjust this parameter, yes. Yes. So if the set point, okay, I will adjust the set point to be 90 bars, yes. And you see the output is go to 100% because the PV is less than. Yeah, I will adjust the PV. Yes. Okay, so it's fast, so we can adjust this one. Yes, it's so fast, right? So we can adjust the gain to 2. or 3. Yes. So it will calculate by gain and this time. Yes. So we can adjust it. So thank you very much for watching my video, and I hope everyone will understand how to create the sample PID control for testing from the touchscreen. Yes. Also create the touchscreen for monitoring and control by adjust the parameters or some variables. So thank you very much, and we will see you next video. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use WinCC Flexible 2008, about how to create the alarm. Okay. If we talk about alarm, there are two types of alarm. The first one is discrete alarm. The second one is analog alarm. So in this section, I would like to show and share about how to create the discrete alarm that can generate from the analog and convert to the digital, and then it will show the alarm when, example, the temperature of heat bearing of generator or earth bearing of generator is abnormal, it will show alarm. Okay. So to create the alarm, I will use the Schematic Manager and WinCC Flexible to create the PLC and screen to show the alarms. Okay. So let's go. Okay, so first open Schematic Manager. And I will use the existing project that we already learned in the previous video. So let's go to find the project name, generator. Yes, it is the existing project. Okay, here. And then we can download this project to the PLC that we already learned in the previous video. Yes. Okay, so we can online. Okay. So this is an existing project that we already learned in the previous video. So for example, to create the alarms, let's create the data block. Okay, I will delete this one first. Okay, so first create the data block. To create the data block, let's go to blocks and then right click here, insert the new data blocks. Okay. And this is data block number 1 example for alarms. So the first one, we double click to create the variables for alarm. Example alarm 1, it is a boolean. Example alarm 1 for heat temperature high. Okay. And for alarm 2, it is boolean also. Initial value 0, it fall. Heat temperature of bearing, right? Heat bearing temperature. Okay, we delete this one first. Okay. Heat bearing temperature high. Okay. And alarm 4, boolean also. Initial value 0 also. Earn bearing temperature high. And for alarm, sorry, this one alarm 3. Okay. Alarm 4, boolean 0, it means that fall. Initial value 0, it means off. 1, it means on. Okay. So earn bearing temperature high. Okay. So let's test for this for alarm first. So I will delete this one and then save the project, and then we can download. Yes. Okay. And then close it. So right now we already created the data block for DB1. So we need to create the alarm here. Which one is the earn? Yes. Heat bearing, yes, here. So I will compare by using this value. Example, I set this one. Okay, let me create here and use the comparator. So CMP for compare. Example less than, sorry, greater than. Yes, greater than equal real. So example this one, compare with the set point that we set. Example 50.0 degrees Celsius. So it will generate the alarm, right? It will generate the alarm. So let me cut here. And then let me insert one more for network. Alarm of heat bearing generator. Okay. So I can paste here. and then I will use the coil. So dB, okay, we can put here. Yes, the table here that we already created. So hit bearing high, right, for alarm 1. So double click here, okay. And for alarm 2, we can insert K like this. This one should be alarm high, right? Okay, alarm high, and we can create one more network. Okay, and then we can use the CMP for compare greater than equal real. Yes. So the output the same. Yes. This one for head bearing, and then compare with the 60 degrees Celsius. It means that if the value of this one greater than 50, it show high one. Yeah. And for this one greater than or equal 60 degrees Celsius, it will show alarm high. Okay, so I will use coil one more and dB, and this one alarm 2 for temperature high. Yes, here double click. Okay, and for the bearing of head bearing, sorry, this one is earth bearing, right? Head bearing, this one should be earth bearing. Okay, earth bearing. So I will create 2 network more, and then we can use the CMP. Yes, greater than equal real. Okay, and then I will use this one, compare with example 50.0 also. One more coin. Yes, so dB 1.dbd 3 for alarm 3, right? This one. Okay, and one more we can copy and paste for high alarm. Example 70 degrees Celsius. Okay, and this one should be alarm 4, right? Okay, and we can comment it a little bit. This one should be high. Of earth bearing, and this one should be high of earth bearing. Okay, and then we can save the project and then download to the PLC and online, and we need to create the alarm on WinCC Flexible, right? So let's go to create the alarm on WinCC Flexible. So open WinCC Flexible software. and then I will use the existing project that we already learned in the previous video. So the project name is generator. Okay, so wait a moment for opening the project. So this one is the existing screen that we already learned in the previous video. So I will create the new screen. Yes, example this one for main screen, and this one for alarm screen. Okay, so to create the alarm, first go to the object, yeah, enhance object. So drag and drop the alarm view to here. Okay, and we can resize the object a little bit. If the screen is big, it also can use easy to view. Yes, so it just example, so I will use this screen to simulation. Okay, like this. Okay, so we need to create the text for alarm, right? So go to the discrete alarms. Yes, double click here, and then here is the text that we want to show on the screen. Yes, to show the text message, it means that alarm message here. So example, head bearing, high alarm, right? Okay, and I will create the new text for alarm. Go to the text and then create new example, alarm text. Okay, and I will use the data type word for this alarm. Okay, and then please OK. Good. And for the trigger bit, if we choose 0, it will start from db1 dot dbdh0, but our point is db1 dot dbdh0.0, right? So I will adjust this one to h. It will start from h. Yes, so it become db1 dot dbdh0.0, the same as this one. Okay, so next we can copy and then paste here. Should be changed to high alarm. Yes, and this one automatically arrange the bits. Okay, so db1 dot dbdh0.1. Okay, and one more for earn bearing high alarm. So earn bearing high alarm, yes, automatically. One more for earn bearing high alarm. Okay, so we just test 4, and this is the address of the alarms, and this is the alarm message. Yes, for show on the screen. So let's test. I will save, and then I will call the screen by using the button. Yes, I will use the button. Example, go to screen alarm. Okay, something like this. Just example. So if the real practice or everyone have the project should be designed to better than me, because it is just example for this tutorial. Okay, so go to screen alarm. Okay, like this, and then I will go to event and then go to click and choose the activate screen. Yes, here, and choose the screen name for main screen or alarm screen. Okay, so I will choose the alarm screen. Yes, screen number 2, and we need to click back, right, from this screen to another screen. So I will copy this one and go to the screen alarm and paste this one. Okay, and this one should be go to main screen. Okay, go to main screen. Okay, and I will use one more button for activate the alarms. So I need to go to property and then go to column, go to display, and here is the option that we can use the acknowledge alarm or edit the button. Okay, so if I press the checkbox acknowledge button, it happen here. Okay, so let's save the project and then use the simulation, because right now I already online the Schematic Manager. Yes, so let simulation. And then go to screen alarm, right? So go to screen alarm. Yes. Okay, I will change this one a little bit. For this one, go to event, press and call activate the screen main, right? Because we need to return to the main screen. And I would like to adjust this one a little bit like this. Okay, and then save the project again and simulation again. Okay, like this. Okay, let's test. Go to screen alarm, go to main screen. Yes. Okay, right now let's see the temperature of bearing and winding around 25 degrees Celsius. So let me hit the thermocouple to show the alarm. Yes. Okay, let's test. Let's see, the temperature will go up. Okay, and let's go to the peg alarm to see the alarm. Right now, here, it occurred the alarm. Yes, because the temperature is over than set point. Yes, let's see the alarm message here. Okay, so right now the temperature is lower than set point. We set point 50 degrees Celsius for alarm high. So right now around 43. So okay, 43 something. So I can press the acknowledge for clear the alarm. Yes. Okay. Okay, I will hit again to let's see the earn bearing also here. Okay, so let me hit the PT100 again. $45, not yet alarm, right? Let me hit again. Okay, alarm occur right now. Okay, because the temperature is over set point, so it appear the alarm. Okay, so if the temperature is lower than the set point here, we can acknowledge. Right now we cannot acknowledge. Let's see here, because it's still alarm. Yes, here around 56, 55. Yeah, it decrease step by step. Okay, so this is a discrete alarm. Actually, we can also create the analog alarm, and I will show and share to everyone in the next video for how to create the analog alarm. So in this time, we already know how to create the screen, how to create the alarm. So if everyone have any project that related to the alarm or show the value of the temperature or voltage or something that convert from analog, yes, to show the real value, everyone can use this step. Okay, so the basic is very important. If everyone would like go to the advanced of learning, we can learn from the basic, and the simulation is very important that we can use it to learn from at home or anywhere that we want. So the first one, we need to have the simulation, and especially if everyone have the PLC module, is also very important, so we can practice for connect the wiring or some function that we want. Yes, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon, and I would like to request all of you to like, share and subscribe my video also, to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I'm very happy to show and share about how to use the software WinCC Flexible 2008 Series Page 5 and Schematic Manager version 5.6 to create the analog alarms. In the previous video, we already learned about how to use the function FC105 to convert from analog to the real values of the phase A, B, C sensor 1, 2, 3 of the speed and time bearing and current frequency. Yes, and also we learn about how to create the digital alarm, or we can say discrete alarms, and also test with the real PLC. Okay, so today I will show and share more about how to use the WinCC Flexible again and the PLC S7-300 by software SIMATIC Manager to create the alarms. Yes, it means that analog alarms. And we also learn about how to change the colors if the value is varied. Example, the between of value from 2000 to 3000 RPM, we can change the color, or temperature from 50 degrees Celsius to 60 degrees Celsius, we can change the color. Okay, so first let's go to our software to create the alarms. Okay, so first let's open SIMATIC Manager. Wait a moment for okay, and I will use the existing project that we already learned in the previous video. So let's open the project that it called generator. Yes, here, and then click OK. So we can go to block and open the OB1, and we can online because we already connected the LAN cable from PC to the PLC. Okay, so we can online. Okay, so we need to create the alarms, analog alarms, follow this value, right? So example, we need to limit the set point. Example, the voltage actually 220 volt AC is the normal level of single phase, right? But this is a generator 3-phase, so we can limit example 380 volts, so we can use the normal color. And if it up to the 390 volts, so it will change the color and it will show the alarm on the analog alarm also. Okay, so the second, we can open the WinCC Flexible. Yes, and I will use the existing project also for create the new screen or new alarms. Okay, so in the previous video we learned about discrete alarms, right? And we use this alarm for show in the screen. Yes, I will simulate a little bit about the previous video. Yes, okay, here is the data in the previous video. Then we will create the analog alarms, right? Here. Okay, so we need to know about the alarm message that we want to show. Example, the generator. Example, voltage phase A over volt. Okay, or we can say voltage phase A over for alarm message. Okay, and I will use the text here. Let's see. It is the volt phase A, right? So go to trigger text and then choose the voltage A, right? Here. Yes. So double click here. And we can limit the number. Example, normally 3-phase it will 380 volt something, right, for 3-phase. So I will limit example 395 volt. It will show the alarm. Phase A is over volt. Okay. And for phase B, I will create the same. Yes. So I will change this one to phase B. Yes. Okay. And for the limit, okay, I will change this one to phase B. Yeah, for B, it means that phase B. And the value I can set the same, or we can set any number that we want. Example, 392 volts. It will show the alarms over volts. So here is the on reaching edge. It means that it trigger. For volt 3, I can also use the volt phase C is over and alarm. I can change the text to volt C and the number 395 also. Okay, example. It's just example for everyone, easy to understand. But in the real practice on the project, everyone can use another text or another value that everyone would like to show the alarms on the screen. Okay, so it's just example. And one more for the current, right? Right now it's 0 to 150 amp. So example, current is over. It just alarm message show on screen, right? Alarm message. Current is over. So I will use the current. And I can limit the number. Example, 100. Yes. 100 amp. It will show alarm. Or 120 amp. Yes. We can set any number that we want. Yes. It will show the alarms. And for the frequency, we can set also normally around 50 Hertz, right? So frequency is over. Okay, I will choose the text frequency. So the analog alarm is very easy to create, yes. The same as the digital alarm. Okay, I will choose the frequency text and limit around 50.5. Yes, it will show the frequency is over. Okay, and for the temperature of bearing, yes, or speed, yes. Example, generator is overspeed by sensor 1. Okay, so I will choose the text of speed number 1 here. Example, normally the generator speed around 3000 before synchronizing, right? So I will choose 315 or 320 RPM. Sorry, 3020 RPM is overspeed. Okay, but we can change this one to be let me check. Okay, right now 3500 RPM. Okay, so no need to change. So this one around 3020 RPM, it will show the alarm over speed. And for sensor number 2 also we can check. Okay, number 2, and select speed number 2 also. And this one we can type 3020 also for overspeed. And for the sensor number 3, yes, we can also choose the speed number 3, yes, and set the limit 3020 also. Okay, and then for temp bearing, right, temperature bearing and binding, we can also set, yes. And then we can use this text because last video we already learned about digital alarms, yes. So for analog alarms we can use this one, yes. Example, there are two options for temperature of head bearing. Temperature of head bearing is high, yes. So we can use the the temperature of head bearing, and we can limit. Example, 50 degrees Celsius. And for alarm high we can also limit. Example, high, and the same text, and we can limit. Example, 60 degrees Celsius. And also temperature of urn bearing is high, and I will choose the text urn bearing. Example, 50 degrees Celsius, and we can copy and paste here for high. Okay, the same text, but the value of limit will increase to 60. And one more for temp windings of generator, right? So we can use this one, yes, for temp winding. So example, temp winding Yes, is high, so I will choose temp winding and limit around 85 degrees Celsius for high, and high around okay, winding. Winding is high. Winding is high. Yes. So the same text, but I will adjust limit to 100 degrees Celsius because it inside the generator coil, so it will hot. Yes. So I will increase the range. Okay, this automatically. So we can save after we created the text, and we can go to add one more screen for alarm analog, right? For this one is digital alarm. Okay, I can adjust a little bit, and then we can copy and paste. Yes, and we will got the new screen, and we can rename the screen for analog alarm. Okay, here. And we can show the alarm automatically. So on this setting, we no need to change anything. We just put here. So if we would like to use the button for clear, we can also use here. Yes. Here is disable. Here is enable the button for acknowledge the alarms. Yes. And we can save. And we can go to the main screen. Here I will copy one more screen to call the screen of the analog alarms. So copy and paste this one for digital alarm. Digital alarms. Okay, and this one for analog alarms. Okay, and go to the event and then change the screen name to analog alarms, right here. Okay, and this one we still keep the same position. Okay, and for this screen we no need to change because we need to go to the main screen. Or if everyone would like to change or add one more for button to call the alarm digital, we can also set. Example, this one go to digital alarms, right, screen. So digital alarms. Okay, and we can go to event and then choose the screen for digital alarm here. Okay, and we can copy and go to the screen alarm and then paste this one to main screen, and this one for analog alarms. Okay, analog alarm, and we can change the event, change this one to analog alarm screen. Okay, so we will got the analog alarms. Okay, when we call the screen. So that's all for this one, and in the next I will show about how to change the color. So simulation first. Okay, then I will call the analog alarms. Okay, this screen. let's see here, no button for acknowledge the alarms, right? So let me check again. Okay, here, so we can go to property and then go to display and then check the acknowledge button. Okay, and then let simulation again. Okay, I will online the PLC. Yes, go to the analog alarms. Okay, no alarm occur because the temperature or the speed is around 2020 2724 RPM. Yes, let's check here. Yes, so it's not alarm. So I will adjust the milliamp to let the value of this generator is high. Okay, so let's adjust together. Okay, I will adjust the milliamp. Yes, to let the RPM and the temperature. Yes. Okay, I will adjust to maximum. And let's see it has alarm or not. Yes. So right now let's see the alarms. Okay. It has alarm. Generator is over speed. Yes. Frequency is over because it let's see here 60 Hertz is maximum. So it will show the alarm here. Yes, because we already setting. So let me adjust to alarm to be lower than this. Okay, to easy way I will select this option. Yes, for 220 milliamp. Yes, easy to adjust. Okay, around 12 milliamps. Okay, and then we can acknowledge the alarm one by one because it lower than setting. Okay, so it not alarms. Okay, so in the next step I will show about how to create the color here. Yes, example 30 around 3000 something, it will show the overspeed and the color is alarm. Yes, so let's go to screen and then go to the main screen. Yes, and go to the speed sensor one. Yes, it's an example, and go to animation. Example, we would like to use the speed one and for the color, and we will choose this one for integer, and then we can change the color. Example 3022 RPM, it will show the color. Yeah, this color. Or we can between also between 3025. Yes, like this. And this one should be example 3030 to 3100. It will change the color, example red color, and also flash, yeah, flashing. It means that blink blink blink. Okay, so it will change the color. Let me save and simulation. Okay, so right now it under the 320, right? So the normal color, let's see the green color. So if I adjust the speed to like this, speed 1, right? Let me check again. This one, why not show the color? It over the set point, right? Okay, speed 1, and then this value should be alarms, right? Okay, let's check here, and then simulation again. (3,500 RPM, right? So why it not show the alarms? Speed 1, right? Okay. So we can test like this. Yes. Let me delete first and then create again. Example 3000 to 3010. It will change this color, right? Okay, so let's test. Okay, the color is changed. Yes. So if it sorry, this one should be like this. So if the RPM around 3012 to 3050, okay, it will change to red color and then blink also. Okay, so we can choose flashing and then simulation again. One hundred 350, right? 3500. change the color or not. Let's see. Okay, so right now it changed color to be red and blink also. So let me adjust the temperature, the RPM to less than the setting. Yes, let's see the normal value. Yes, and for another speed sensor we can also set like this. So I will adjust this value a little bit. Example from 3010 RPM to 3025 RPM. It shows this color. After that 3026 to 3500, it will change to this color. And this one also, yeah, the another speed sensor we can also do the same procedure. Yes, okay, do the same procedure. So go here and then choose the speed tool and then choose the integer and go to the value. So here we can choose 3010 until 3025. It will change to this color. Yes, and this until the 3500, it will change to the red color and also blink. Yes, and this one also speed 3 integer also, and the value is between 3010 RPM to 3025 RPM. It will change to this color, and from this to 500, 3500 will change to the red color and also blink. Yes, and for another temperature or current, we can also set like current integer also. Example from 100 to 120. It will show this color, and from this to the maximum, example of 150, yeah, it will show the red color and also blink. Yes, and then we can simulation, yeah, for test. Okay, so easy to understand about. If we see the touch screen, we can check the color, then we can fix the problem if we use the color for show. Okay, so right now we adjust the RPM and current of generator to be change the color. Okay, I will adjust. Let's see, the color is changed because it high. Yes, and if I change the current, let's see, the current is also changed. So if I adjust step by step, I can select here. Yes, right here, and can adjust. Okay, can adjust to be lower. Yes. Okay. So we can show the current this color. It means that the high one setting and this one is over speed. Okay. So this is about how to create the alarms, analog alarms, and change some color that be easy to see on the HMI. If our temperature or RPM or voltage have problem, we can see the color for easy to understand. Okay. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my videos. I will reply soon. And I'm also sorry if I have mistake in this video also. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.